Good morning. Hello. How are you?
Good morning, everyone. Wilna here from NSTF. Wilna Extern. Hello, Prof. Gledhill.
Hello. Hello. How are you?
I'm well, thank you. Good to meet you sort of in person on Zoom.
Yes, exactly. Good to meet you. Or maybe Zed meet you.
Yes.
Good. How are things? How are things with you there?
Oh my goodness, it's
You must be
going very
extraordinarily
well.
busy.
Very busy, yes.
Okay.
Yeah. And
Yeah.
yourself?
Okay.
And yourself?
Extraordinarily busy. I'm retired, and I'm far busier than I was when I was employed.
Yes, I
So
see
it's,
that.
it's minute to minute.
Yes, I see that with all the professors. They retire and then, they're still contracted and very busy. And yes, it's wonderful to see.
And of course, it's up to us now to decide what not to do.
Yes.
And of course, we're now impelled by all the things that we think we've figured out or are just beginning to learn, that we're
Yes.
just beginning to understand now. Oh, there's Yancy. Hello,
And
Yancy.
there's Yancy. She's been there all the time.
Okay.
Morning, Igle. How are you?
Very well, thanks. How are you?
Good to see you. Yeah, I'm well.
Good.
Morning, Wilna.
Yeah.
Morning, Yancy.
And morning, Prof Iwuoha.
Oh, yes, I see he's also there. I'm sure Itu is
Good morning,
making...
everyone.
Good morning.
Hello,
How are
Prof.
you?
Fine. Morning.
Morning. Good to meet
Was the
you
first
as
to
well.
join.
Yes.
Hmm.
Okay, I'm just going to go on
Hello,
mute
there's
to post it.
Thanks,
Okay.
Wilna.
hello, Tumaleng. We're at last seeing each other.
Yeah.
Good morning.
Good morning. Thank you for all the communication. It helps a lot to know that I can get in touch with you fast if I need to.
Great. Thank you. Itu, are you able to share your camera?
Okay, I'll do that now.
Okay. Morning, Prof Mashifana.
Yeah.
Morning. Good morning,
Good
everyone.
morning. How are you?
I'm well. How are you?
Fine, thanks.
Good
Good to see
morning.
you.
I don't know what's happening on my side because my camera is on, but then I'm
Oh.
not up here. It's only my background.
Ah! Oh, sorry. Itu is missing, people. And morning, Ashley.
Morning, everyone.
Hi, you were also here first.
Yes.
Thank you. Are you well?
I'm much better than last week. Thank you.
Good. Good.
There have been some nasty bugs going around.
They have, haven't they?
Yeah.
People have been quite ill.
Yes. Yeah, it's time also for flu injections, I think.
It's sorry? Excuse me?
Time for flu vaccination. The influenza is
Yes.
is going around. Are you hearing me okay, Yancy?
I'm hearing you okay. I just wanted to make sure I understood you.
Quite.
Yes,
Yes.
there's a bit of
Okay,
a
is that a little
delay.
better?
Yes, that's good.
Yes.
Is there? Okay.
Yes.
Right. Okay. We are having a bit of trouble with networks in our environment, but I think I won't try and swap routers right now because we're just on the edge, right?
Yeah. I see one student so far.
That's pretty good for this time in the morning.
Yeah. Well, the good thing, everyone, is this is being recorded and it will be on our website. So
Yes.
the students will also listen to it on their own time.
Well, I always register for things that are actually clashing with something else. And
Yeah.
then I find I never actually get to the recording.
Yeah.
And so I miss out on understanding large chunks of what's happening in the world of discovery.
Yes, yes.
Yancy, just to keep you posted, it seems like some of the students are saying that their Zoom link is not working. So in the WhatsApp group, I've just sent them the link that I'm using. So
Yes.
let's hope it will work. So that might be the delay on their side.
Yeah. Thank you, Wilna. Thanks. I see that.
Okay.
Okay, well, I think we should start. So welcome to all our speakers. Thank you very much for making the time out of your busy schedules to join us and to talk to the students. We know from experience that this is a very valuable program and that the students appreciate very much hearing your stories of your personal experiences and your careers. We have the speakers in the Zoom. We also have Rumana and Riavula, who went to London for the London International Youth Science Forum. And I think that is it in terms of students, but it's wonderful to have them here with us as well. They got back from London just very recently, and they had a wonderful experience seeing the wider world and meeting people. So the purpose of this program that we have is to, on the one hand, expose students to experienced researchers and see that they are real people, that they can be spoken to and can be networked with and can follow as role models. And it is for the award winners also to have a chance to express, to formulate their work in a way that is interesting and accessible and to be inspired. So now I see that there are more students joining us. Good. I think it might have been the link, Itu. Might have been the link. So it's a very good experience, I think, for an exchange from both sides. And it becomes a permanent record in the form of a recording. We don't actually write it up, but it is a recording which we share on our website and then on social media as well and in our newsletter. And so there is potentially thousands of people who can benefit from this interaction. There is some time for questions, although it is quite a packed program, and I encourage the students to ask their questions. So think about what you would like to ask the award-winning scientists. You can also post those in the chat, and then I can read them out to the speakers to answer them. It is good to see some names in the Zoom. It's been quite a long time since our tour already. It's now spring and we met in cold Cape Town in winter for the tour, and that was quite an adventure which I was privileged to go on with you. I think that it was an eye-opener for all of us in terms of what is being done in South Africa and the well-kept secrets of just the fantastic scientific work that is being done in South Africa. This is another such occasion. It is something that you won't see on TV, you won't find it on popular media or even social media, because this is a chance to encounter the best of the best in South African science. So I hope that all of you enjoyed today and that you find some benefit from it that will help you in your lives going forward. I also hope that you keep in touch with each other in some way and that you can continue to interact beyond today's session. Right, Vilna will be posting in the chat. There is the link for everything about today's program. So the event page is there. It's the today's program, as well as the invitation and the biographies of the speakers. Please have a look at that. And she'll be posting the biographies of speakers as they come up as well. Vilna Ekstien is the NSTF COO, Chief Operations Officer, and she is responsible for the awards project as a whole. She was working in Cape Town during our awards gala dinner. So many of you didn't get to meet her in July. Okay, who else should I introduce? Itumeleng and Ndlovu, everybody knows, because she's been bringing all of this together and coordinating it. Thank you, Itu, for all the hard work that's gone into the Brilliants program, the LIYSF, and today's program. Ashley Pala is also a member of staff as an intern. She's got a master's in physics, and she's busy working on her PhD. And we are glad to have her with us as well. I don't know who the other staff member is there. There's another NSTF person. And then Bernard, the students will know Bernard from the tour. He also worked on the tour, and he is responsible for our media outreach. He's our communications officer. Okay. With that, I think we are ready to kick off with the first speaker. Our first speaker, we're honored to have Professor Tebogo Mashifana. She is, sorry, let me just, she received the T.W. Kambule NSTF Emerging Researcher Award at the NSTF-South32 Awards this year. And she received many other awards as well, which you can read about. She is an academic and leading researcher in the circular economy. She's head of Department of Chemical Engineering Technology and an associate professor at the University of Johannesburg. She is pioneering innovative solutions for environmental sustainability. Prof Mashifana, most hearty welcome to you, and we look forward to your presentation.
So much, Chance. I hope the students are here, they're well, and yes, I see a number of them have already joined. I don't know if you're going to be projecting my slides, or should I project from my end?
Itu, how does this work?
You can share your slides, and then if maybe there are projects, I'll be able to share on my side too.
Okay, let me just share. I'm not so familiar with Zoom, but documents.
You have to click on the document itself and then click share as well.
I've got it. Thank you.
Okay.
Please let me know when you see it.
Yes, it's up.
Okay. Thank you so much once again for this invitation.
Perhaps just put it on a slideshow as well, Prof.
Okay.
There, perfect.
Yes.
Okay,
So
please go ahead.
Thank you. My presentation today is on navigating the transition, and I'll be sharing some insights and strategies for success in university STEMI programs. I was actually saying, just thanking NSTF for this great opportunity. I was just reflecting about everything today, and in preparation for this session, to also reflect on my own personal journey. And I feel very honored to be speaking to the young minds, brilliant minds, and really having the opportunity to plant a seed this morning, hoping that there is something that the students now will get from the sessions today, from all the speakers, and it is actually going to be some of the tools and the strategies that they will use moving forward as students and beyond that. So with that, I just want to congratulate the students, the first year students in the class of 2023. And as I was reflecting also on this, I think one thing that came very strong into my mind and my spirit was, if you were to be, when they say that against all odds, you'll be the personified to actually fit that description very well. Because often you find that it's only the students or the learners that are from a certain class, or even the schools that they attend, that will be able to excel academically. And I think based on where you come from, your background, which is what I will share, I just want to say that well done, that against all odds, where you come from did not actually determine where you will be. So you are doing well, you are brilliant, and it is really an honor to be here today and sharing this conversation with you. So I thought that I will actually start by sharing a bit of my background. I've already been introduced, but so I always say that I am a woman or a girl from a village, and this picture really depicts that very well. To say that I'm a woman that grew up in a village in Limpopo, in a small village called Sihlakwane. And in the middle of the slide that I'm sharing here, it is this young girl that had a dream. I had a dream as a young girl, even though I did not know how that dream will be achieved, but I ensure that I do not lose that dream within me. I had a dream. I remember, I think when I was about 12, 13 years old, I remember my parents asking me, what is it that I'm going to be when I grow up? Or what is it that I want to do when I go to university? And there's one thing that I said to them, responding to that question. I said that I'm going to study until I become a doctor. And then the only doctor I knew was a medical doctor. But I think it's really around when I was around 20 something, early 20s, going to my 30s, somewhere there, when I actually realized how the words that I spoke when responding to my parents were becoming a reality. And I obtained a doctoral degree at the age of 30. And I think for me, then when I was reflecting on that and what I said as a young girl to my parent, that even though because of the limits that I had in terms of understanding the careers that are available, but I always knew that I would become a doctor. And that dream really is what has kept me, I think, going into the university. And I have put it there in the middle to say that, yes, there's this background that everything else from where I come from said I cannot be where I am now. But there's something that was burning, and I ensure that that light that was burning does not switch off. And on the right of on the screen here, it is actually that university that I saw myself going into a university, even though my parents did not even have money to pay for my fees or my studies. And I think also the reflection and also reflecting on that and how blessed you are that you have done so well from your matric results. And there's this precious opportunity, if I should call that, to ensure that you are able to study. to ensure that you are able to study, you are able to actually fulfill that dream that you had. I remember a year prior, my going to university, asking my parents about what is it, do they have funds, do they have plans for me? I had an elder sister that passed on, so we were both in grade 12. And my mother said something. She said that we do not have anything. We did not save any. We don't have a cent to take you to university, but God shall provide. So you can imagine, this is around November, December, a year prior, me going to varsity, and that is the only word that I got from my parents. But for whatever reason, I actually ran with that word. I ran with that word. I remember coming to Johannesburg when I got here without fees, without any plan. God really provided that year. And from that year, my first year in varsity, I actually got funding. I got a bursary that was funded my studies throughout my career at the university. I'm very grateful for that. And I'm just reflecting on that to just show you that you are indeed a drop in an ocean, that there are many other learners that will never, ever have this opportunity where they have done so well, and they actually have the opportunity for someone else to recognize the excellence and that the excellence and the talent, and make a decision to fund them. So also I want to just reflect on, you are in the STEMI program or STEMI careers. All of you here, you have chosen to do or pursue STEMI careers. It is not all there. It is not only about being in a STEMI field. It's not only about being clever, being brilliant. I've actually highlighted there to say that it is not only cool, but it is also necessary. That is the important thing, because often you will actually, maybe you make some of the decision to say that I'm going to study this, but not necessarily understanding the importance of doing that. And I just want to really touch on that to say that what we have chosen to do is not just a decision that we have made because it is cool to be a scientist, it is cool to be an engineer, but there's actually a need, there's an urgent need for you to be doing what you are doing. There's an urgent need for you to get to the other side, and when you get to the other side, begin to contribute to some of the pressing challenges that we are experiencing in our world. When you begin to talk about STEMI programs, we're now beginning to look at innovation. So there is innovation. STEMI programs exposes you to the mind or the thinking of being innovative and coming up with a solution to some of the problems that we are experiencing. The STEMI programs or STEMI careers, they foster creativity and problem solving, leading to technological advancement and new solutions to pressing global challenges that we are experiencing. I think when you're talking about, or we even think about problems and bringing solutions to that, we are already thinking about economic growth. That some of these challenges, or most of them, some of these challenges that with the mind or the skills and knowledge that you acquire through the STEMI programs, you are going to begin to contribute towards the economic growth by providing solutions to some of these challenges. And the other one is addressing the global challenges, as I've already indicated, that we begin to now play a vital role in tackling some of these issues. And we can think about, there's a vast or a variety of these problems, from climate change, the healthcare, energy sustainability, food security, environmental pollutions, and so forth. It is through the STEM-related fields or program or careers where we are beginning to gain some of this knowledge and tools to be able to contribute meaningfully. You have the opportunity to improve the quality of life. Advances in STEMI field contributes to the improvement of life in so many ways. I've already indicated, when you're talking about someone that is handling or dealing or conducting projects related to environmental pollution, water pollutions, they have a background or knowledge in STEM-related fields. Other one is enhancing education, whereby you begin to, you will see it. It's your first year, but I'm sure you're already experiencing that, where through education in these programs, you're already beginning to think critical about some of these issues. You're beginning to gain the analytical skills. You're beginning to collaborate. I think through the program itself, this program, brilliant program, you're already beginning to collaborate with your peers and so forth. And moving to the next one. So that was just there to say that it is not just a cool thing to do, but it is a necessity. It is a necessity and an urgent one that we need you on the other side. We need you to get to the other side successful as we have entered into the program. We do not want to lose any one of you in the process, because that is another reality, that STEM-related programs, most of the times you look at the statistics of people that are entering into the system in the universities and the people that are exiting the system, especially on record time, you'll see that there is a significant decrease in that. So I hope that what all of us or the speakers here will be sharing today is to actually empower you to know that I can actually be, even if it's that 30% that is able to get to the other side successfully without being lost in a system. I have the capabilities, I have the abilities to actually be that one. And so moving to the next one here, these are some of the challenges. Some of you, I don't know if you have begun experiencing these challenges, but these are some of the challenges that you are going to experience. If you are not experiencing these challenges, definitely going to experience them as a student. And I'll just touch on them and also try to provide some solutions, because I've experienced this as a student. Many of my students are also experiencing this, and there's always a solution. I just want to say that there is always a solution. Giving up in the process is not an option. It can never be an option. The first one that I've added there is the financial constraint. I should have actually somehow included a strike through in that, because I think in your case, this might not be applicable to some extent, because you are blessed to have been given the opportunity where your studies are being funded. And the second one that I've seen many students struggle with, especially students that come into the system, and these are students that were performing extremely well. So I'm from the University of Johannesburg. Where I am, we call these orange cupboard students. And there's a different name for different institutions. These are really students that are performing extremely well. Students that are at your level in terms of performing. I've seen that some of these students, when they get to the university, they actually struggle. They struggle, whereby now what they've done or what they've achieved in a high school or matric, it does not translate to who they're becoming at the university. And simply because when you get here, and because this is almost, the year is almost over, you have experienced all of this, you see that, you know that you have experienced that when you get here, there is no one that is an example. There's no one that a teacher or a lecturer is not going to be following up on you. You'll be blessed to actually, even if you're in some of the lectures, the class are too big, a lecturer will not even recognize you that you are in that classroom. And if there are lecturers that will not even take a register in class, the lecturers that will just show up in the classroom to transfer, deliver knowledge, and they carry on with their lives. And if you have someone like that, it means that you can, if you are not able to go to class to attend your lectures, there's no one that is going to follow you up. Unlike when you're in matric or high school, if you do not show up at school, your teacher will be concerned, your principal will be concerned, your parents will definitely know that you are not at school, and someone will follow up and find out what is happening. So it is that, and because in at high school, it's more like I would say that at high school level, I mean, the opportunity or how we study, how you prepare is completely different from at the university level. And then the next one will be the social integration. I'm from Limpopo. Me coming to Johannesburg to study was a shock of my life. for the first time, I was seeing all these big buildings. It's a different, completely different culture from where I come from. And as a young girl or young woman coming from a village somewhere in Limpopo, I mean, I was not exposed to most of the things that are happening here. But I think what really kept me grounded is not forgetting where I come from. So you will have, in terms of you integrating, because you also in your classroom is no longer same kids or same learners from the same environment, same background, same community. You have different people from different backgrounds, people that will be coming from different classes even. And if you forget why you are at the university, why you are here, or why you came here in the first place, those are some of the things that might actually be a challenge to you as a student. And a lack of support system. It is important that you actually create that support system. It can be through friends, a community of friends that you will have and say, this becomes my support system, because you will need that. It is not like in high school where you know that every single day I go back home, my parents are there, my siblings are there. There is that support system. Sometimes you might not even have the opportunity or time to speak to your parents at home, back home. You may not even have access to your parents back home or your family back home. But you need to ensure that you create that support system within the university. And when I was a first year at varsity, those were the two friends that I had. Two friends that I think my values aligned with their values, and we grew together. The emotional and mental health challenges, many students do experience this. And I'm aware that many universities, they have facilities, they have programs that they are running to ensure that while you are busy studying, your emotional, your mental health are also taken care of. Please ensure that you find out within your university about these services. These are services that are freely available to students, and you need to ensure that we are making use of these services, because varsity life can actually become hectic in most of the times, especially for top performing students. And I've heard will be they get here and they do not do as well as they expected that they will be doing. Sometimes that thing hit them very hard. You know, they begin to now question their intelligence and all of that. You need that emotional and mental health support. Universities across the country, or I'm aware that most of them, they do have these services. Please ensure that you use them. And I mean, I've also had experiences or heard stories of learners that will fail an assessment for the first time in their life at varsity. So you can just imagine that all your life you are this top performing student, and for whatever reason at varsity, you get here, you write the assessment, and you are not getting a 90 or 80. It's actually a fail, or even a 50%. And so you can imagine that if you do not have the strong system to deal with that, even that can actually hit you very hard. So it's important to do that. And most of the time it's not because there's something wrong with your intelligence, or all of a sudden your intelligence has changed. Most of the times it's also the issue of now you trying to adapt to the new system, a system that is completely different from what you know, or what you're familiar with back home. Access to resources, you need to know that the resources that are freely available within universities. Know about these resources. You might be struggling that I'm supposed to be conducting research. Where do I find resources for that? There are libraries within universities. All of these resources are readily available and freely accessible to students. So if it has to do with your studies, or even your professional, your personal development, resources are already available within universities. Just ensure that you find out about these resources. a language barrier. Let me not go deep into that one, but it becomes a challenge. I know for me it was a challenge from a family that speaks Zulu to now suddenly come to university, and I'm taught 100% in English, and I need to communicate with English. So what I did for with me really, and trying to also learn how to communicate in English. The friends that I had were speaking completely different languages. I think that for me really helped, because I was forced to communicate in English. So if maybe some of you might be experiencing this challenge, because I also know of students that they will be excelling in all the technical related subjects, but when it comes to communication skills, a module in communication skills where they need to stand in front of people and communicate, that becomes a challenge. Balancing responsibilities, that is very important. You need to have plans to ensure that you are actually balancing your responsibilities. The number one reason and goal why you are here is for you to study, is for you to excel, is for you to complete on record time and get that degree on record time. Independency, I've actually added the question mark there. Is it independence or is it freedom? Some people might actually abuse this independence and freedom, because there's no one that follows you up. There's no one that is going to check if you've done your work and all of that. And then that becomes a problem. The truth is, if you are not able to lead yourself, it will be a challenge. So you need to develop those skills right away. And I'm also conscious of my time. I just wanted to share a few insights from my personal experience. I've learned that it is important, the friends that you keep and the company that you keep will actually determine how you get to the other side. So it is important that you keep friends that are aligned to your vision. I've spoken about friends that you need to have people that you know that the main thing that is combining us as friends is actually for us to get degrees. You'll find so many cultures, so many things that students will do instead of really focusing on their studies. You do not want to be one of those students. So I will really encourage you to ensure that you keep a company that is aligned to what you came to the university to do. If it is something else where instead of studying, you find yourself, you are clubbing, you find yourself doing things that have nothing to do with your studies, I can tell you now that the end for that will not be the results that we are desiring. Your responsibility towards your studies becomes very important. And that is not just in the classroom, in and inside the classroom. It is important what you do. And I've learned that for me, when I was a student, I will ensure that when I'm in class, a lecturer is teaching me, that I understand everything that is being taught. If I struggled with any concept that is taught, I will ensure that I consult with the lecturer, I consult with the tutor. That is important. Do not leave things until the end, until it is exams time. And then now you're beginning to open the pages of your books. You're beginning to ask about things that you did not understand in chapter 1. The truth is, chapter 1 to chapter 11, most of the times in the modules that you'll be doing, that is a build-up towards chapter 10. So you can imagine that if you actually ignore that there's something that you've missed in chapter 1, you might actually go to chapter 2 all the way to chapter 3 without understanding what is happening. And if you actually do make that mistake, you'll find that when the assessment comes, it becomes a problem for you. Daily routines and activities are important. The main thing why you are here is for you to study. Please use the opportunity to study, is to get to the other side with that degree. Academic excellence and the doors that he has opened for me, it is not only how you entered here excellently as you have done it, it matters how excellent you become through the journey. I mean, the NSTF award, it is not an award that was just random. It is based on the work that I have done as a researcher. Academic excellence, I received a number of awards because of my academic excellence. The reason why I was funded throughout my studies is because of academic excellence. So I just want to say that, and I don't know if there's a case here, but I know that even most of the funders, that they will not say that they are not committing to funding you for 3 years without you delivering what you need to deliver. So that becomes very important. So these are some of the strategies that I would like to share for you to have a successful career in the STEMI programs. Effective time management. You need to know what you're doing when you need to be doing it, and do not waste time unnecessarily. Utilize campus resources. I've already indicated that. Engage with faculty and mentors. There are those resources that are available. Actively participate in your classroom. I know that the students that normally participate in my classrooms are the students that I will know, are the students that will actually begin to develop that relationship. When they're experiencing whatever challenge, they're able to come to me. Hands-on experience. There are many experiences that are aligned to the field that we have chosen. If those opportunities are presented to you to be hands-on, always raise your hand to do that. Develop a strong study habit. That is the only reason we are here. That's the only reason you are where you are in the university you are at now, is for you to study. So everything else is secondary. Embrace collaboration. I've already touched on that. Cultivate resilience and adaptability. You need that to actually excel. There are so many challenges that you're going to experience, which some of them what are actually shared previously, but you need to adapt to that. You need to develop and cultivate that spirit of resilience and adaptivity. Your health and your well-being becomes important. Please do not ignore that. Stay informed and curious. And I put a big question mark on social media. I always say that if you're on social media, you are using a different platform on social media, if it is affecting your study, delete it. If you are on if WhatsApp, you're not using WhatsApp to study, and you find yourself spending more time on WhatsApp instead of studying, and it end up affecting your study, delete WhatsApp. There are holidays where you can download it again and spend time on WhatsApp. If it's Facebook and Facebook is affecting your study, delete Facebook. I've done that. I remember I was not a student. I was actually a young adult working and all. About 5 years ago, I deleted Facebook, not deactivated, deleted it in my devices. I've never been on Facebook for more than 5 years now, because it was affecting my productivity. So anything that affects you in what you are here to do, I will say that please delete it, unless you are using that tool as a stepping stone to where you want to be. Stay motivated. It is important. Stay motivated. Attend programs such as this. Learn from your setbacks. It may be the first time. I shared an example. Someone fails an assessment for the first time. Learn from that and pick yourself up. Build a support network. I've already touched on that. Practice self-care while you are doing this. And just to close, this is my last slide. This is what I actually want you to take from the presentation here. Stay away from distraction. That is the first one. Recognize that you are special. For you to be in this program, you are special. And not everyone who is clapping with you and for you want you to see you successful. That is the reality. So you need to be intentional about staying away from distraction. And there are people that friends, wrong crowd, that because you are well known. South Africa knows you. They might not be after you, but they might be after that excellence and trying to distract it. So anything that is not aligned to that, stay away from it. Always remember why you are here. There are so many distractions that you're going to come across. Remember why you came here. The end goal is that we are completing on record time with excellence. Record time excellence, and we're getting that degree. And I think the big one is that you are a hope to so many people. Back home, your parents, your family, your community, you are hope to that. Keep achieving success. It is not only about entering at the university with success. The world needs your excellence to address some of the pressing challenges that we are experiencing. Thank you.
Thank you, Prof Mashifana. Thank you for your wisdom from your hard-gained experience, and sharing it with us in such a clear way this morning. Thank you for that. If you don't mind, we'll share your presentation online on our website. Thank you very much. And we'll move straight away to the next speaker because our program is tight. Thank you once again.
Thank you.
Our next speaker is Professor Irvy Gledhill. She's also known as Igle, and I have no idea why, but this is how I know Prof Gledhill. Lovely name. She is visiting adjunct professor of flow physics at the University of the Witwatersrand, and she hails from the Eastern Cape. For 30 years, she has specialized in transonic, computational fluid dynamics at the CSIR, and she's contributed as an applied computational physicist within multidisciplinary collaborations, including rational drug design, ocean engineering, and coal mine safety. So she knows a lot about applying physics in various contexts. She is the winner of the first Science Diplomacy for Africa Award under the NSTF-South32 Awards, and we welcome her to talk to us this morning. Professor Gledhill, please go ahead.
Thank you. And my gosh, thank you very much for the chance to be here with all of you. Please, could you all just unmute for a moment and say hello so that I know you're here and that I'm not speaking into a vacuum? So if you could just
Hello.
Hello.
Hi.
Hi.
Hello.
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 Oh, hi. Great to be here with you. I am very, very happy to be here. Siyabonga kakhulu, Professor Tebogo, for your words. I did identify with them too. I've had rough times and smooth times. I understand what high expectations are like. So take a relaxed attitude with me for the next few minutes. I followed a bit of an unusual path. That's why I've entitled it as Being Close to the Edge. Some images I'll just go through a little bit fast, but I'd like to leave a bit of time to maybe hear from you. So Yancy, could you give me a 2-minute warning by switching on your video and maybe saying something if you need to? I'd be grateful for that.
Okay.
Great. So I think I've been a bit on the fringe. Instead of walking a specialized line for my whole life, I've been between disciplines, across disciplines, pushing boundaries, making people annoyed, and hoping to live up to my own expectations. And I have been changing, growing all the way through, multiple mindsets, I'd say. So let me be a bit unconventional by starting off with some conclusions. One of them is that academic research or traditional academic research, not now, and I realize this, often has a particular solution. In one's early career, in particular, you find a solution, it's brilliant, and then you look for different research directions for application or for progress. I've lived a lot of my life in a different place where the question is often clearly articulated, difficult, you don't know how to answer it, the people asking it don't know how to ask it properly, then you still have to find a solution and test it, and you need to bring in everyone that is relevant there. Just as an introduction, I grew up in Makanda near Gledhill in the Eastern Cape, and to Rhodes University. I'm a rodent as a result, high on life, and went into plasma physics, that is hot gases, at what was the University of Natal and is now UKZN. I did my first postdoc at University of California, Los Angeles. At that time, and still, we are hoping to build power stations by confining very hot gas in magnetic fields. It's called magnetic plasma confinement. I was doing computer work on that, computer simulation. This is a Cray 2 computer. The reason it's circular like that is that it takes just about a nanosecond for light to travel, communication possible. I've put in a couple of computational things because I think some of the brilliants are going into ICT and computer science. My second postdoc was at Stanford University in a laboratory called StarLab. And the problem that was posed was that the space shuttle, which you're seeing here, glows when it's moving, or did glow when it moved, on its forward surfaces. So you know that it's actually moving upwards in this picture because that's where the glow is. But it wasn't known why. And I was working on computer simulations of that. So I was working on the Cray 2 in assembler. That's right down at the most basic code that you can get. And also using a massively parallel processor at Goddard Space Flight Center. I came back to South Africa, and you might wonder why I didn't go to a university but went to the CSIR. My boyfriend and I had been chasing each other around the world for years, in fact, and we finally wanted to settle down together. He is my husband. We have a daughter who's a filmmaker, and the two-body problem, when you want to stay together, often means that you end up in a big center. Even if you come from a relatively small city like I do, finding two research jobs for two people means you might have to commute, say, to Pretoria in my case, to Johannesburg in his case. But I want to emphasize that part of the mandate of the CSIR is to contribute to the improvement of the quality of life of the people of the Republic. So it has a very clear aim, which is not an aim to publish more papers. It's different. I first worked in complex systems. I'll talk a little bit about this, but I'm going to move on fairly fast. Here is a little system. It consists of 9 tiny blocks, which can be on or off. And there are rules that say, if you don't have enough living blocks around you, you go off. If you have just the right number around you, you stay on. If you have too many around you, you go off. And there are a few more rules that are needed to make it work. And if you just run this on a computer, it's called Conway's Game of Life, you can see structures emerging. But this is just a little rule that has to do with on and off. I switch off under some circumstances and switch on under others. And the reason I was doing this is if you make one on a triangular grid with rules that you can work out, you can mimic the flow of fluid past, in this case, a cylinder with all its swirls and vortices behind it. And so these things are called lattice gases. They might solve fluid problems in very complex geometries, like the inside of a motor car engine, very complex geometry. And I was working on transputers, which are like little computers hooked together to each other. They're all talking to each other. Then there was a strategic change at the CSIR. You will come across strategic changes. Suddenly your projects aren't there anymore. Your beloved research has disappeared. You have to work in terms of generating income to pay salaries. And I went into aerodynamic prediction based on computer fluid dynamics and simulations. And you always have to check validation. In aerodynamics, if you are not sure that your software, your code, what you've written is valid, you endanger lives. For example, in aircraft. So I worked in a system where I used computational fluid dynamics and worked with the people who look at wind tunnels. This is one where air blows down. You put your little model in over there, and it blows out to the atmosphere there. My particular interest was in work near the speed of sound, transonic, and with moving bits. So it became clear to me that simulation is an aid to thinking. Experiment leads to simulation, which you check with experiment, adjust your simulation, and understanding is generated as you go around this. Let me introduce the concept of systems here. Right down at the bottom, in a working environment, this was an engineering environment, we have baseline capabilities, like textbook solutions, putting your feet up on your desk and thinking, using modern design of experiments, which is a field on its own, databases, mathematical methods, more complicated mathematical methods, big simulations, the kinds that take a week to run on massive computers, wind tunnel experiments, and flight test. We certainly worked with flight test data. And all these go up a level to be integrated into mechanics, aero databases, and flight envelope generators. And those you can't use unless you have project capabilities, how to contract with people who want this work done, how to integrate those technical capabilities. So I started to understand not only complex systems in terms of dynamics and physics and mathematics and simulation, but complex systems in terms of people. How do you get on with all these people? I'm always astonished that people can work with each other long enough to make an aircraft that doesn't fall out of the sky, or to make a skyscraper that doesn't fall down. For a computational physicist, there's always another bug, right? You're always chasing validity of your code and getting rid of bugs. This is the first reported bug ever. Here it is, it's a moth. And this one was actually located, this page is preserved, I think, by the Smithsonian in the USA. It was reported by Grace Hopper, who was one of the very first, if not the first, PhD in maths at Yale University in 1923. And she wrote processing compilers and was one of the authors of COBOL. She became a rear admiral in the US Navy. People don't always know about women who've done things like this. Because I could do simulations, I was pulled into methane explosions in mines. In South Africa and all over the world, explosions of methane and coal dust cause considerable fatalities in coal and gold mines. You'd be surprised, there is methane in gold mines. It outgasses from the rock. And the Safety in Mines Research Committee wanted to know whether simulations could be used towards preventing mine explosions. And the answer I was able to come back with was yes. But of course, I investigated the business side of this. Who needs this? How much are they prepared to pay? Is it viable? Yes, you can do it with reasonable confidence. But mine experts already know what to do. Of course, I went and talked to the people who go around mines in gumboots. I went down mines. I had to overcome the barrier that women are considered unlucky in mines. And court cases are usually decided on non-technical grounds. So if you're an expert witness, you might not be called on at all in order to say where this explosion began or what to do for safety. Then, this is an evolution of a mindset that you're seeing here. From 2006 onwards, I was increasingly concerned about the global crisis of HIV, and I was thinking about how can a physicist, a computational physicist, get involved to contribute to a solution? I'm not afraid of collaborating. One builds bridges, both technically in terms of learning the vocabulary, going up the learning curve, and in terms of working with people. And so I was able to come back with a question from a literature survey: how fast do single base mutations take place in HIV? That was my first question that I had to tackle. And then I was involved in a project, what might good lead molecules, those are treatments, that's drug design, be for tuberculosis treatment. And for those who are in the biosciences and doing MP-CHBs, this is going from Newton's laws to glutamine synthetase, which is different in the TB organism from humans. And that's what you want. You want to exploit that difference with the treatment. You want to kill the TB bacteria, but not kill the human cells. Then it became, and I'm just giving a little bit of detail here on the bioscience side, how to metals complex with adenosine triphosphate. I learned density functional theory and started to look at what features are shared by good lead molecules for HIV. This is HIV reverse transcriptase. It's a bit like a, I'm just seeing if I'm holding my hand up the right way, like a hand. If you look down it, the green bit is like my thumb, and the purple bit is the palm of my hand, and the red bit is the fingers coming round. And the RNA or DNA comes through this gap, and that is where it's transcribed. But you can jam this enzyme with a drug by putting it in a particular active site there. Oh, I should go back one. We were picked at the post by one of the major laboratories in the UK with this one. So you need to understand about patenting and speed. I decided to use those skills. The next problem was how to protect the eyes of aircraft pilots. At that stage, young people especially were waving green lasers around from the ground, and these can disorient and even damage the retina of pilots who are on landing, which is the most vulnerable part of the flight. So I did density functional theory. This is a phthalocyanine molecule with zinc in the middle. And I was looking at the electronic structure to see whether it would suddenly exclude exactly the right wavelength of that green light. I was working with the best. I had the pleasure of working with Tabelo Nyakong at Rhodes, and she independently moved ahead in using this kind of molecule for the treatment of tumors. You paint these things onto the skin and then irradiate it with lasers. Amazing to work in a group like that. So for me, this one didn't work. Time ran out. I hadn't grasped everything properly enough. I learned during this project about hindsighting. What do we want to do and how do we work backwards from there? That was key to the way a heterogeneous group works across disciplines. But you also have to learn to let go when it's not worked out, and not be miserable and not get imposter syndrome, where you think that you are incapable of succeeding, contrary to all the evidence that there is. You just keep going, wipe your eye and keep going. And that was where I got in, to think about the ladder of success, where you've done all this work, but you were chasing the wrong thing, or perhaps in the wrong way. Now, during that time, we were asked a question: what is the drag of an ocean wave on a Delos? You might think that this has nothing to do with molecules and all the other things, aeronautics, for example, but it does. For a computational physicist dealing with fluids, the sea is a fluid, the air is a fluid. And we actually worked out what the real question was. A Delos is one of these big concrete blocks. This is a picture of Cape Town. You can see the Gledhill and eThekwini as well, Durban Harbour. They're used there to break the force of the open the waves coming in from the open sea, and protect the harbour and the real estate and the ships. So we figured out that this wasn't really a fluids problem. By the way, one can simulate these things in a model hall. There's one down in Stellenbosch at the CSIR. So we made a model of the Dolosa moving around, bumping into each other under the influence of ocean waves. And we came up with some answers. We can look at whether this is organized or disorganized by referring to liquid crystal statistical physics. And that comes from looking at how long thin molecules like this one line up in liquid crystals, and liquid crystals are used in the display of your cell phone. So this was taking theoretical ideas from theoretical statistical physics and applying them in what looks like a completely different field. And that is such fun when you realize this. That is a real aha phenomenon. Around that time, I became interested in accelerating aerodynamics. Not much has been done in it. And so, of course, I felt challenged by that. And this is the Bloodhound supersonic car. There it is. I was looking at the aerodynamics of these shock waves, which can endanger the car when it's under acceleration or deceleration. So my conclusions are that, yes, you have this solution that leads to different applications, and you have this application over here, but in between, there's a lot. Now, around about this time, I became involved with the International Union of Pure and Applied Physics Working Group on Women in Physics. There is a problem. We need to address it. Oh, you might recognize here, this is Malala Yousafzai, who won the Nobel Prize for Peace, and who also helped this group of women in physics from all over the world to understand her conclusions. And I became involved in an enormous project with the International Science Council, the Gender Gap in Science, was involved in a survey. The dark indicates where we had a lot of respondents, 32,000 respondents across the world, lots of different sciences. There were 8 international unions, including astronomy, maths, biosciences, and so on. And we held a workshop here in South Africa to test the questionnaire. Was it applicable to Africa? How were we going to disseminate it? What would the answers mean? That was such fun. And I became involved with academies, the Academy of Science of South Africa and the network of African science academies, which covers all the academies within the African continent and its islands. And this engagement was a mind stretcher all over again. Here is the key, one of the key problems. Africa produces the least greenhouse gases, but it is the most vulnerable region. The red. Whoops, I'm so sorry. Am I still screen sharing? Let me just check back again.
Yes, you are.
Okay, right.
No
For some
problem.
reason, I can't see my own slides at the moment. I'm just going to double check what I'm actually showing.
Yeah, it's the slide saying, but Africa is the most vulnerable region.
Yes, okay. Not quite sure why I did that. That's Africa is the most vulnerable region. The red here is an index of vulnerability. And of course, the global south is in danger here. It's least equipped for adaptation, and climate finance is what's critical here. And here is a mind that was learning all this, okay? Stepping out onto the edge, saying, okay, I'm a computational physicist, but let me grapple with this. This is urgent. Climate justice is still largely to be explored. So you're now working with lawyers. You're now working with global finance, and definitely working with astonished scientists across our continent. And that led to me feeling rather perturbed, physicists, and I'm going to talk about being a physicist for a moment, we're used to and observe being part of the system because physicists are human and we're in the universe. I love this quote. The eye that surveys the universe is the universe's own eye. As I look at my screen at the moment, I am a product of our universe. But we're not looking after it very well. And I will explain this image in a moment. You might notice there is a little blue dot there, a pale blue dot there. This is a quote from Carl Sagan. Look again at that dot. That's here. That's home. That's us. This is a picture of the Earth. It was taken by the NASA Voyager 1 spacecraft in 1990. I'm not sure if you were alive at the time, but if you were, you're in this photograph. And those are the terms I started to think of. It's difficult for the public to understand the uncertainty of scientists. We deal with precision and accuracy and confidence limits. Most people don't. We know about things that are nonlinear. We know about chaos. We know about, I've put up some physics terms here. We know about catastrophe theory and about systems analysis, which I talked about. And we're aware that we live in a non-equilibrium system. Things won't be the same forever. The reason I've put up a picture of El Nino surface temperatures, surface sea temperatures here, and La Nina there, is that this is beginning to look to us a lot like a bistable system, like this chaotic system. This is one where one is plotting 2 parameters of any system, and it evolves into this state and jumps into that state and comes back to this state. And we're beginning to understand that. So there's a call to action. Climate change, the issues are set to grow in the coming years. They're connected with the need for energy security and sustainability of the environment. And this is definitely multidisciplinary. So once again, one's on the edge. So I became involved with Professor Nozipho E in founding a new working group for the International Union of Pure and Applied Physics for climate change action and sustainable development.
Prof, just 2 minutes.
Great. Now, we're getting to this question about what is science again? What does science do and how is it evolving? And there is a new report out from the International Science Council, which talks about flipping the science model, a roadmap to science missions for sustainability. Because we are worried about sustainability, whether we are contributing in terms of deep knowledge of health in South Africa and Africa, deep knowledge of systems, and this is definitely system science now, deep knowledge of energy and how to generate energy renewably. Key messages of this report are we need to fund and undertake science for the SDGs differently, the Sustainable Development Goals, if we're to put humanity and the planet back on a path towards long-term global sustainability. And for science, this requires an additional mechanism beyond the traditional science model. Now, I know this is happening in many of your minds, and it's also happening in science. Mission-led science is that new model. It's the questions that need to be formulated. The stakeholders need to be pulled in, all stakeholders, not just some, and definitely not just the sciences. So there is a mission, which includes Naledi Pandor, calling for scaling up investment in science to strongly and sustainably support transdisciplinary, that's right over to lawyers and financiers and community members and indigenous populations and vulnerable populations who are refugees, support transdisciplinary and engaged mission science for sustainability. And we're back on the edge because here we have deep knowledge, and there's a nice model that you can have deep knowledge in your specialist area, but enough superficial knowledge to be able to talk with other people in order to address a question, even formulate questions which are hard to formulate with oceanographers, with earth scientists, with lawyers, with people from different populations, community development, and so on. And critically, test your solutions. Thank you. I'd love to engage if there's a little time, Yancy.
Wow. Okay, that there isn't actually.
Okay.
But we do have some time at the end.
That's cool.
At
No problem.
1:10.
Yes.
Will you come back or stay on?
I will. Yes, I will.
That'd be fantastic.
Wonderful. Great to have been with you.
Thank you so
Thank you.
much, Igle, for this very insightful presentation. And there is so much in it that I think we'll all have to go back and read it and think about it. It certainly says for me that to solve the problems that we have currently, we have to look at the power of collaboration, very important, the power of lateral thinking and creativity, never settling and thinking that you've arrived, the power of physics, that's non-negotiable, and the power of lifelong learning, because you are such an example of that for us. Thank you very much.
Thank you all.
Gledhill.
Cheers. Thank you.
Our next speaker is Professor Emmanuel Iwuoha, and my apologies if I'm not pronouncing it correctly, Prof.
You pronounced it perfectly well.
Oh, thank you.
You practiced very well.
Prof Iwuoha is an A-rated scientist of the NRF, and he is the South African Research Chair for NanoElectrochemistry and Sensor Technology and Professor of Chemistry at the University of the Western Cape. You can read his biography on the chat and on the website. He received the Award for Engineering Research Capacity Development at the recent NSTF-South32 Awards. Welcome, Prof Iwuoha.
Thank you. Let me see. Sorry, just 1 minute.
Yes, I can see your slides. Yes. And they're in presentation mode.
So, good morning. I'll be talking about opportunity and opportunity costs. So it may be a bit different from what we have. So I'm going to look at the introduction, what are opportunities prevailing, desired, and engineered. Opportunities you have as students and brilliants, call to leadership, attributes of leadership, effect of loss or ignored opportunities. Then I'm going to talk about this leveraging opportunities. So when I'm talking about that, I will then show a few things about SensorLab, which is the application of opportunities. So I want to thank the NST for this opportunity to speak and share my views, about how to be a brilliant student. I also want to congratulate the 2024 NSTF Brilliant cohorts, and particularly for their outstanding performance. How can I remove this? Okay, for their outstanding performance. And as you see, my talk would be on, sorry, I have this thing that is coming. My talk will center on the opportunities and the cost of opportunities we take. So the introduction, as very young people, you'll be presented with a lot of opportunities, but what is important is that the choice you make would eventually decide what you become. Now, it's not always, the first speaker, all of us said about her history, and she didn't allow her history to overcome her. So our sociological imperatives will always be there, but they should not define us. So the opportunities we have and the response patterns, particularly our response patterns, but the opportunities will be there, they will determine our competitiveness and our success. Rather, they will determine how we overcome situations and improve our life and those of other people. So I would like to look at it this way. I look at opportunity differentiations. So I would just take three. I'll look at opportunities that come in form of prevailing circumstances, the opportunities that come in form of the things we desire or ambition or our vision, then the opportunities we engineer ourselves. So in terms of prevailing circumstances, we have opportunities that present themselves. So these are sociological, political, natural opportunity, later resulting from the laws of natural selection. So there are opportunities that present because of where you live, where you are born, the political system, the things that are occurring where you are. So those opportunities is the survival of the fittest. So where we are born and government policies and maybe the inherent gifts and talents we have, they determine this type of opportunities we are talking about. For example, you may be highly successful because of both your sociological and biological DNA. But in addition to that, because those are the things that may give you the passion and determination and the resilience to withstand and overcome challenges. Now, there are opportunities we seek. All of us dream dreams. All of us want to be this or that. Your parents also have, these people around you want you to be that. So all those desires and ambition, generally, I would call them our vision. So those are the opportunities we seek. So the thing is that the very successful people do not have to sit down and wait for people to provide them information. They go out there and look for the information. So the opportunities that are available to them help them to attain their goals and use talents. For example, this age, a lot of information we can get from the internet. Now, one of the highest levels of creativity, one of the highest opportunity level is the engineered opportunities. So the opportunities we create. So even if we are given or provided opportunity or we seek and find opportunities, we should all aim at creating new opportunities for ourselves and others. I mean, these are the only things that change the world. The opportunities we create, for ourselves and others. For example, everybody talk about Facebook, we talk about Apple, iPhone, Microsoft, computer age. All these are opportunities created by others. So we should, even as we go to school as brilliants, we have to begin to think in terms of creating, not only consuming opportunities, but we have to also create. So the reason is this is the highest dimension of opportunity hierarchy, the ones we create. And whenever we create opportunity, it adds value to society. A few years ago, we never had cell phone. If you want to make a call, you run to the phone booth or you use a wire telephone from Telcom in your house. But now you can speak to somebody, see somebody that is in Russia and discuss. It wasn't there before. So it's very, very transformational, and it transforms the culture. People form network. You have all these new terminologies we call netizen. You have a lifestyle, you have blogs. So those are transformational and, cultural transformation and lifestyle transformation. And also, if we create opportunities, it gives us confidence. It gives us reason for being on this part of eternity. You know, it improves our self-concept. And so it also has, so on its own, it motivates us to do more. Okay. So what are the opportunity costs for those of us who have been selected as brilliants? But before we go into it, let's look at some of the stats we have in South Africa. As of yesterday, September 5, 2024, the population of South Africa was estimated to be 64.14 million. 10.13% or 6.5 million are in the age group of 18 to 24 years. Why did I choose this age group? These are the age group that's supposed to be in from first degree to honors. Now, but it would surprise some of us to know that only 11.6%, or specifically 754,000 of this particular age group are attending any form of a tertiary education, including university. So of 6.5 million, only 754 are attending school. Some of them, the others that are not attending, many of them are not even employed. Now, let us also look at the budget the government puts in education. So the country puts 6.06% of its GDP, which is a total of 135.6 billion in 2023-24 in education. And if you compare it with many other countries, you can do that search later on. You see that South Africa is one of the countries that that have the highest GDP budgeted for education. Now, but what is important is that only 11.6% of the 6.5 million 18 to 25 years are attending tertiary education. Now, what does it mean? It means that only those who are schooling are benefiting from that 1.35.6 billion. So the government is investing in those people. So what happens to the other people? So that's the question. In other words, the real cost of educating any of the brilliants and all the people in the university or tertiary institutions, the real cost of training them is the 5.3 million that are not in school. So these 5.3 million are catering for, the 754,000. What is the implication? The implication is that we have to pay back. We have to assume responsibility for planning for these people. So in other words, we have to be leaders. So as brilliants or university students in general, it means the country is investing in you. The country is entrusting its future into your hands, because the life of this country depends on you, the young people. So the country expects you to be the custodian of wisdom, culture, knowledge, skills, expertise, creativity, passion, integrity, discipline, and social capital required to transform the country into a better place for all people that live in it. Okay, I will read this. I say, incidentally, and it is then only natural that the opportunities you have as brilliants is actually a call to leadership. So it's not just opportunity to go and visit London. I'm not saying that it's bad to visit London or, get scholarships, but you have to understand that there's a responsibility that comes with this. And you are leaders, so the whole world is looking up to you and all the other people that are in school at this time, because there are 5.4 million people who are actually paying for this. They are not in school. So what makes us special that we should be the people in school? So we have to assume this leadership and take care of the rest of the people. So the fact that only 11.6% of these people is at the university or is receiving tertiary education places that huge responsibility on, firstly, the Brilliants and all the other young people at the university. It means that naturally or inadvertently, as part of the 11.6 million, you are future leaders. It is important for the Brilliants for you to understand that you are leaders. Because if you don't understand you are a leader, you will not create opportunity for others. You want people to create for you, which is one of the small problem we have in the country. Because that's why we have about 37% unemployment amongst 15 to 34-year-olds. So because of inability to create opportunities for others. So we are waiting for other people to create it, government to create. So this applies not only to the Brilliants, but also to everyone. So the leadership I'm talking about is the moral authority you have rather than a formal authority. So the opportunity you have, gives you that incontestable moral authority and huge responsibility to prepare for leadership. So when you are preparing for leadership as Brilliants, as the leaders of the leaders, because what NSTF has said now, based on your performance, they're giving you the opportunity to be the leaders of the leaders. So you don't take this responsibility. You have to be competent. You've gotten all sorts of advice this morning about how to work hard in school. So you have to be competent. It speaks of the possession of required skills, knowledge, qualification, capacity, because the problem is that incompetent leader or mediocre leaders, they create chaos in society. So it's important for you to reuse the resources. Now you have to have goal attainment habits. It's similar to what you've heard this morning. So you, as an effective leader, you have to develop consistent and sustainable way of approaching challenges. So you have to be visionary. So effective leader, you require discipline and high sense of responsibility. So because many people look up to you and many people depend on you, many people say, oh, you are in the university, you are going to come up with a degree, you are getting training, so you are coming up with a lot of ideas. So you have to be a person of integrity. Not having honest habits leads to mediocrity, so which can be disastrous to the organization. You have to be a very good role model. And you have to have influence. An effective leader should be able to influence people. Remember that people will judge your actions, principles, integrity, and willingness to understand them, their fear, motivation, and frustration. People don't want leaders that are only thinking about themselves. They want leaders that understand their situation and do things to help them. So there should be an attractive and captivating humility and confidence about your demeanor. That's about your character. When people look at you, they see that, they know that you are very competent, but you don't be arrogant about it. So another thing we need to talk about is let us look at a situation where you did not use these opportunities that you are given. And all the 54,000 people we have in the university, they are not using the opportunity given to them. So what are the consequences? So first of all, let's look at what the World Bank calls extreme poverty. It says people who are earning less than 1%, $1 per day. You may be surprised, but there are people who are not earning up to that. So in South Africa, surprisingly, according to STARS SA of this year, 18 million people, which translates to 28.6% of South Africans, live in extreme poverty. ladies and gentlemen, this calls for serious intervention from those of us who have the opportunity of, having, been trained with resources that is available. So we have to know that 28.6% of South Africans live in extreme poverty. So those with opportunities have the responsibility to improve the lives of other people in the country where 28% of the population are in extreme poverty. So having said this, talked about all these opportunities. So I just want to share an example of how we use small opportunity we are given to create something that benefited so many other people. So I'm going to show just one example, the example of SensorLab, the creation of SensorLab, or what we call the University of Western Cape Sensor Laboratories. I do apologize that I'm moving very fast. So I come from this university, University of Western Cape. So most of the research in the sciences go on in two buildings. This state-of-the-art building, that houses about 5 departments and 6 institutes, which is this building. Then the other research goes on in this chemical science building. Now, the University of Western Cape Sensor Laboratory occupies the entire 4th floor. Now, we didn't start like that. We started with one tiny room, a room that is actually about 2 meters by 4 meters in 2002. With one student, everybody rejected. So, but where did we, until we got, I think it was Naledi Pandor who came and saw how crowded, because we started expanding and expanding. So she had to give us the, 200, I think she gave us the seed fund of 200 million rand around when she was the Minister of Education, the very first time she was. And that's how we got that building. And so we occupied the 4th floor, because when she came to our lab to see what we are doing, she was surprised because she didn't expect to see what she saw in UWs, but we were occupying 7 labs at that time, and it was packed with instruments and people, and there was a lot of health hazard. So the new sensor lab we have in that ultra-modern building has 11 laboratories, and it was founded generally, like I said, not the building, but the lab itself was founded in 2002. We focus on functional materials for sensors, photovoltaic, and electrochemical energy like batteries and supercapacitors. Now, one good thing about this lab is it is the only center of its kind that was not built or established by any university or governmental project or initiative. It grew up organically. So anybody can create something. I remember when I came first at the University of Western Cape, I told them I want to develop a center. Some people say, "Oh, what do you mean? How do you think you can do that?" I said, "Don't worry. Let's see what happens." So that's all I said. So you have to know what you want to do. Again, the importance of being creative. Using the opportunity given to you. They gave you opportunity, be in the university, use the university, as a fulcrum to do whatever you want to do. So you don't go there and just teach and go. You have to create something, add value to the university. So that's how we ended up having this building, and all these, our laboratories, even undergraduate laboratories, are ultra modern. So this lab is made up of these 11 laboratories: energy, graphene microscopy, polymer, enzyme, immunosensor, spectral electrochemistry, and so on. The lab can house 64 postgraduate students at a time, and 8 academic staff use the laboratory now. 2 SARChI chairs, myself and Professor Baker, 48. So we've been able to implement that. This is just in the last 10 years. We implemented 48 exchanges sending overseas, and we received 35 exchanges. I'm not talking about professors, I'm only talking about students, the exchanges. And the lab has graduated more than 110 PhDs and more than 120 masters. So that's the impact of the work we're doing. And most of these people are highly successful professors in their own rights, all these graduates, mainly in South Africa and also in different parts of Africa and including Europe. So just to give you a view, so this is where the students write. On the right-hand side are the offices, the labs, the experimental labs are in the middle. Then the instrument lab, there are 4 rows. The instrument labs are on the far left. So you see a typical, this is our battery research section. So these are students, these ones are in their writing chairs, you know, this side that I showed you before. And then we are highly equipped. Like I said, we grew up organically, but we're one of the most equipped electrochemistry laboratory in Africa. So that's why it's easy for us to have exchanges, because usually our students, if you're doing PhD, you must spend 6 years in another laboratory. So when they go out and come, sometimes they find out that what we have is better than what they went to see. But it's always good for people to go other places where it's not their comfort zone, so that they should experience and see what is going on there and learn how to be competitive in another culture. So I just want to show here that we are not just South Africans, we graduate, we also, you know, graduated people from other parts of the world and other countries. And we also, part of the impact of our laboratories is that another creation is that we have this MSc Nanoscience, which was the first of its kind in Africa, and then it's actually funded by DST. The hub is in our university, but it involves University of Johannesburg, University of the Free State, and Nelson Mandela University. So, but lectures go on here for 9 months, then the students will go and do their projects for 15 years in their university. But we use our facilities in SensorLab to do their practicals. This is all part of our postgraduate labs. Just to give you an insight of our labs, how they are. Okay, so what do we do? I said it's nanoelectrochemistry. So we develop electroactive materials which we apply in developing disease diagnostic sensors and in energy storage and energy generation. So I will go very quickly just to show you example. So I have the ones we call soft materials, hardened organic materials, and composite material. So these are typical type of materials we produce and use in our work. These are the other one, previous one is soft material. These are hard materials. So these are, you know, customized materials we use in solar cell, you know, because these are casterites. We try to look for alternatives for expensive silicon. So I show you example here, the design and performance of zinc-doped lithium manganese silicate-based supercapacitors 3 cell. Supercapacitors is that they are supercapacitors and also batteries. So they behave. So these are some of the design of material in testing some of our material for supercap properties. And then people are familiar with the coin cells. So those materials, we use them to develop coin cell and test them. So some of these are patentable. Then some of these materials also we use for solar cell. So instead of having silicon in this black area, we have our casterite material. For example, this is a nickel zinc casterite. So that is a nickel zinc casterite. So instead of using silicon, which is highly purified silicon that is very expensive. Now, another area where we apply our work is in the development of sensors, particularly disease diagnostic sensors. We can call them immunosensor, enzyme, genosensor. So the sensors, particularly electrochemical, so that's why we call electrochemical transducer. If this is what we want to detect, we need something that will recognize it, and then it will give us a signal which will tell us the amount of this particle or this material that is in the sample. So we apply this, we use all these type of biological elements in our work. We use enzymes, we use antibodies, we use DNA, and certain DNA sequences we also call aptamers. So for example, here, we are looking at this particular example. This particular example is talking about breast cancer sensor, which involves the detection of a breast cancer biomarker. We call it HER2. And then here we are looking at the detection of the level of drug after the doctor administers drug to a breast cancer patient. The most administered drug is tamoxifen for breast cancer. The question is, for some people it works, some people it's slow, some people it causes toxicity. So the doctor should be able to, when he is at the clinic, know what quantity is suitable for the patients. So we fabricate this type of sensors. So another area we do is developing new type of sensors for TB diagnosis. So using TB biomarker, for example, here we are using the type of biomarker we call interferon gamma. So, ladies and gentlemen, in conclusion, I've been able to just give you a view of what we are doing, what you can do in science. But more importantly to me is that your realization that you are leaders, that you are selected for leadership. And so the take-home words I would give you here is that gifted persons are sometimes on their own. Sorry, this says on their own. That X is a mistake, because they are driven, passionate, and employ complex analytical approaches to solve problems. So it can be a little bit lonely, but I want to assure you that it is not abnormal. So when you find yourself in that situation because of you are focusing on trying to excel, focusing so much, because it's those people that change the world. Do not mind, it is not abnormal. And a leader should possess an attractive, captivating humility and confident demeanor, born out of solid knowledge and expertise. Again, remember I said it's not good to be a mediocre. You must have, a very solid knowledge. I always tell students, you don't need to know too much. Know, if you're a researcher, know one thing and know it very, very, very well, so that people go around and around looking for the person. Even if they don't like you, they will come to you because you are the expert. So, but for you to get to that level, your knowledge has to be very, very solid, so that your expertise will be incontestable. So you have to be attractive, with a captivating humility and confidence, that is based on your knowledge. So, ladies and gentlemen, the real cost of educating one person who attends higher education in South Africa is the approximately 8 persons who do not. This is very important, the real cost of educating one person. So any one person that is in school, it should be very clear to you that you are one, there are 9 of you, so you are the one that is going to school, the other 8 are not in school. So you must do whatever you can to make sure you use that opportunity given to you, use it very well, because there are 8 other people in your group that are not in school. So they told you to be in school, and those 8 people are actually funding you directly or indirectly. So I want people to begin to have a paradigm shift of how they think. You know, not that I'm in school because I'm supposed to be there, or I'm so brilliant. Yeah, you're so brilliant, but now there's a responsibility. You have to cater for 8 people. So those with opportunities, whether presented, discovered, or created, have the responsibility to improve the lives of other people in the country. Because we have 28.6% of the population that are in extreme poverty.
Prof
So,
thank you.
Thank you very much.
Thank you very much, Prof Iwuoha, for that inspiring, passionate presentation. And it's fascinating what your lab is doing. I think, you know, the brilliant students attend other universities, mostly the ones that are ranked on top. But I think they must take note of the excellent work that is happening at other universities in South Africa. We really have expertise all over that is world class. And when they are creating these opportunities, they must think of collaborations across South African universities, because that is how we can solve the problems. Thank you very much for your presentation.
Thank you.
Thank you. I'll move on straight away to the next presentation. It is by Mr. Leo Chiloane, who manages the Ulwazi node at SAEON under the National Research Foundation, and he's responsible for implementation of data and information platforms. This Ulwazi node won the NSTF-South32 Award for Data for Research, and he will be talking about leveraging networking and collaboration for career growth. Mr. Chiloane, welcome.
Thank you, and thank you so much for the invitation to speak. Just to confirm, can everybody see my screen before?
I can see your screen, yes.
Is it moving to presentation mode?
No, not yet.
So, about now?
Yes, there it is.
All right.
Okay.
Thank you so much for this invitation. So after receiving the invitation, I had to reflect on what propelled my career. And I actually thought of 2 things. One was networking and collaboration. That's why I titled this talk this way. It really is a privilege to be addressing the Brilliants, and congratulations on your metric performance. So I'm probably the only speaker who hasn't chosen a research-focused career, and my career trajectory has really been non-linear. So hopefully I just want to share the key lessons I've learned along the way, but the main takeaways are around networking and collaboration. So I will start with my journey. I grew up in Nelspruit, and I studied at the University of Cape Town, starting from 2007 to 2011. So in high school, I always wanted to be a chemist. So that's the direction I always saw myself in a lab working that way. I got a scholarship to study chemistry as an undergraduate degree. But after the second year, I was really struggling because it was not the right path for me. So I had to navigate that change on what do I move on to. So I tried to pick up multiple courses along the way and eventually added ocean and atmospheric science as a second major because I found it more geared towards my interest, that environmental sciences field, inclusion of data analysis. But that really propelled me to move on to a career in geographic information systems because I was more drawn to the representation of data and manipulation of data. But yeah, I just wanted to reflect on some of the challenges I experienced as a student. And one of it was that in high school, I was very brilliant. So I came out with very good results. And it was quite effortless to get those high quality marks in high school. So I took on that complacent attitude with me to university. But I can tell you that that complacency almost made me drop out because I really, really struggled. So I think the key lesson here was just to avoid complacency. And I was always used to working on my own and approaching problems on my own. So asking for help was really a difficult thing for me. So I think the key lessons I learned while I was at varsity was just avoid complacency, especially if you are coming in as a brilliant student. You might think, oh, you have this in the bag, but you really need to work hard. But yeah, and ask for help if you need it. And one of the key challenges as well was that I never really developed relationships outside of studying. So coming out of varsity into the workplace was a real struggle for me because I didn't even know where to start. So one of the key lessons I had to learn was how to build relationships. So what I did then, I started like sending my CVs to potential organizations aligned with my interests. And SAEON was one of them, actually. It was in a particular application, so to speak, for a specific job. What I did is that I sent my CV to HR. And a couple of weeks later, I received a call that the chief information officer of the organization would like to talk to me. And out of that, I really got offered an internship that was kind of interdisciplinary because at the time his office was undercapacitated. So he was taking me to all his meetings and exposing me to different skills, different people, different organizations. So I think the key lesson drawn from that was the role of mentorship in shaping one's career. So if you can, please do try to find a mentor very early in your life. And again, as I've said, I was always reserved and not reaching out to people. So I had to develop those interpersonal skills as well in stakeholder interactions. But of course, it was an internship, so I was looking to move on. And being trained in GIS, I always saw myself as kind of like a GIS consultant. So it was my dream job. I moved on to the private sector, but worked for various organizations as well as a GIS consultant. But this role for me, although it was something I always saw myself doing, it was a challenge as well, because there was always something missing after being exposed to so much during my internship. So one of the things I had to overcome here was the fear of change, because what happens if you find yourself in the ideal job you always saw yourself in, but you're no longer interested in it completely? So what I did then is that I started reaching out again to other people, especially my former manager who was at SAEON, the Chief Information Officer. So he called me in for a discussion on what I foresee myself doing. And really what I saw myself doing was being embedded in the whole information system program he was running. So an opportunity was created for me as a program analyst working under him. And I think this is what really propelled my career, because I was able to join multiple working groups. I was able to interact with clients at a very high level. So your government stakeholders and funders, and lend a lot of skills in the process. So I think one of the key lessons here is don't be afraid to reach out and try to network as much as possible with professionals in your ecosystem. And because my career was progressing rapidly, I found myself overcome with imposter syndrome, because I was always in a room surrounded by very, very senior people, very specialized people. And that was something I really had to get over very quickly, because as the projects were coming in, I was expected more and more to take on a leadership role per se. And this really propelled me to start looking at what do I do next. And at the time, the position for the management of the Ulwazi node, which I currently occupied, was vacant. So I was put into that in an acting capacity. I didn't think that I would do it. I would be able to do it, that is, because it's a role that involves coordination of 4 specialized team, data curation, which I already had most of the expertise in, data science, ICT infrastructure management, and systems development. So these are very specialized functions. Although I knew a bit about all 4, I wasn't confident that I'd be able to take that on right away. But what really drove my interest even further was the role of collaboration in kind of coordinating this type of work and working with these specialists. And then I realized, oh, I can actually do this, but it does require building relationships, relying on other people. So each of those functions now has a very specialized team lead. So my leadership, I draw from their experiences as well. And I think just reflecting on the whole journey, I think collaboration for me was really the key, because I took on this role at the age of 33. Normally people occupying it are way, way older and have decades of experience. But I think building strong networks and relationship was what gave me the confidence to move forward with it. So what do we do? The work that we do is coordination on the management and delivery of collaborative open science data infrastructures. As I've mentioned, it's got 4 areas. So I manage a team of infrastructure managers. They are coordinating the management of physical ICT infrastructure hosted in Cape Town, Gledhill, and Pretoria. And then there's the data curation function, which is responsible for data standardization and publication, including data governance processes, interoperable standards, and data infrastructure and sustainability metrics. This is my area of expertise, so it's what I was always comfortable in doing. But at some point, I did find there's a need to evolve. And then obviously, I also manage a team of systems developers. So they are responsible for the overall design and architecture of our systems. And then there's a data science team. So this team comprises of people doing research and people involved in the conceptualization, design, and development of data products to assist with the interpretation of data and its translation into knowledge. So we do offer opportunities to a variety of professional backgrounds. And one of the key things I like about this role is that it gives me the ability to offer opportunities to others. But the main takeaway, again, as I've mentioned, is collaboration. And I took this quote, which says, "No one can whistle a symphony. It takes a whole orchestra to play it." Hang on. So what I'm trying to do with this triangle is just trying to map the field of practice and opportunities within this R&D and open science space. As mentioned, I always saw myself in the middle of the program management side of it. So I wanted to move to the center of the triangle. But if you look at the vertices, it comprises of areas around science and core research. And then there's a knowledge management area and engineering, infrastructure, and systems. So what opportunities or skills are required for this to be in this ecosystem? So in the science and research space, it's where we are really looking for the specialists as researchers. And then those involved in knowledge management might be interested in things like being a librarian or an information officer. And then in systems, the purists would be your systems administrators. But because the work itself is collaborative and interdependent, you often find that you need people with dual or multiple interests. So the progression of that, you can see that, so this is to just highlight that some of the opportunities that you can explore if you're interested in a career in this field, that we do offer opportunities to people with statistics background and core data scientists, engineers who are able to solve complex issues. And for people with both science and knowledge management research, they might be involved in both the knowledge management aspect and data governance processes. And then as you progress in your career, you want to sort of move to the center. That's if you don't want to be a specialist. So really, the core skills required to run this whole process are held by generalists. That's what we've often found, because you really need to have an eye on everything that's happening. So potential additional careers might include policy support, being a systems auditor, systems architect. So those would be the people who are in the driving seat of this whole thing, and being a program coordinator such as myself. So there's data center manager. So if you're ever interested in discussing anything aligned with these roles, you can get in touch with me. I've tried to avoid linking these to specific domains or disciplines of practice, because we do appoint people with interdisciplinary skills. For example, my data science lead has a background in archaeology, and you would normally not think of such a person to lead a data science team in an environmental research organization. So, yeah, because my career trajectory has not been linear, there are some tools and techniques that I use to evaluate whether there's a need for change. And I always approach it by looking at it from two facets: the ability to do something, am I able or unable? And my attitude, am I willing or unwilling to do it? So if an activity might involve something that I'm unwilling to do and unable to do, my advice is to avoid such things. I think this could also help you decide where you want to, what you want to pursue as you navigate throughout your career. And then if I'm unwilling to do something, but I'm able to do it, this is what I often find, that it leads to stagnation, because people get comfortable in certain situations, and they might not longer be interested in their role anymore, but might stick to it anyhow because they're able and are good at it. But that's where you really need to evaluate your decisions. And if you are lucky, you might find something that you're able and willing to do. There, you really need to further develop your skill and become the expert in that field. But I find that the opportunity zone lies in when you're willing to do something or have an interest in something, but you're unable to do it. And this requires you to step out of your comfort zone. So learning is important from that regard. Yeah, just some concluding remarks and practical tips that have helped me along my career journey. Rule number one, I would say, know yourself. It's really important to establish those boundaries, know what you're interested in, and know where your pressure points are. And keep an open mind to new things, but don't be afraid to say no. And secondly, I would advise you to surround yourself with people you trust. So number one, I've already outlined the role of mentors, but really do find people who can give you constructive feedback. It doesn't have to be all positive, but find people you trust and collaborate with your peers. Don't compete. And then often something that's overlooked in STEM is the development of soft skills. So communication, speak up when you're in a room, be visible. Try not to leave a discussion without putting in a word or two. And then listening is the other side of communication, of course. And what I've often found is in interacting with experts is that most of them struggle to listen to what people are articulating. So pay attention and listen to what people are saying, because that feedback really helps. And then do your best in everything you do. Only compete with yourself and don't be afraid of failure. I always say that most of my regrets would come from things I haven't tried, but if I did my best and failed anyway, I see that as some form of success. And then start your activities with the end goal in mind. Just think about who would be the beneficiaries of what you're doing and what will be the overall impact. That can help you evaluate whether you're on the right path or not. And then, of course, lastly, don't forget about the personal aspects. So feed your brain, read. My advice is just read everything, including fiction, because people sometimes often overlook fiction and think, oh, I'm not going to learn anything, but read everything, fiction, nonfiction, things that are in your area, experience new things, physical activity, and don't forget to sleep. I will really end it here. And hopefully you found this useful. And
Thank you very much, Mr. Chiloane, and thank you for keeping perfect timing. Thanks very much. I'm so glad you went into more detail about this thing of the imposter syndrome. It's very common, and it's because we have this idea, I think, that you have to be a particular kind of person to assume a particular kind of role. And it's often just an illusion. It's something that we fabricate in our minds. So I'm very pleased that you went into that and that you gave us such a good overview of the kind of area in which you find yourself, which is very much transdisciplinary, and the role particularly of the generalist, because that's something we forget. In the scientific space, we all think we have to be experts in a particular discipline. But the generalists are the glue that hold everything together, and very essential indeed. Thank you very much, Mr. Chiloane. I'll move on to the next speaker, as we have now run out of time. And I want to apologize that our program is so tight, but I also think that it is very productive indeed, in that we're getting such rich presentations from the speakers. Professor Patience Mthunzi-Kufa is our next speaker. She holds a PhD in physics, biophotonics, from University of St Andrews, Scotland. And she is the first known person in South Africa to qualify for a PhD in this field of study. She's currently employed at the CSIR Photonics Center as research group head for Biophotonics. She has many accolades. The one we're most proud of is that she won the T.W. Kambula NSTF Award for as emerging researcher in the recent NSTF-South32 Awards. Welcome again, Prof Mthunzi-Kufa.
Thanks, Yancy. I think you and I need to move into the same building, because it's like we are sharing similar spaces more often now.
Yes, exactly.
Okay, so thanks, Yancy, for the invitation this afternoon. I'm actually on sick leave, so I had a bit of a flu last week, and I'm recovering from that. So I just hope, my voice will keep and I'll be okay. But if I do need to take a breather, I'll do so. So please do excuse me.
Okay.
Thank you so much for the invitation and the opportunity. Even though I am on leave, I just felt, it's something I do not want to miss out on. It's such an honor and such a pleasure to be talking to these brilliant minds. And I want to once again congratulate them for making it this far and for being in the different programs that they are in right now. It's for a reason. It's not just a coincidence that you find yourself where you are right now, with the brilliant marks and the grades that were announced on the night of the award. I was so impressed. So congratulations to the class of 2023, and congratulations also to making it this far. So, as I say, you are so important to me that I just felt it doesn't matter if I'm working or not, I will make the time to engage you. And I have been also listening, and benefiting from the speakers before me. And I'm just thinking to myself, how fortunate, how blessed is this group of people that they have such beautiful motivational talks and role models talking to them, really. It's really something that every child out there, every first year student needs to be exposed to. So please do not take it for granted. It's something that's of value. Right, so maybe just to dive into my talk this afternoon, after I got the invitation, I thought to myself, what would be a relevant topic to address? And I also was conscious of the fact that there could be many speakers. So what could be something that's different, that will bring a fresh perspective, and that's not going to be equally the same to the speaker before? So I thought of maybe let's try to take a journey into the next 10 years, okay? And I also followed the guide that we got from NSTF as to how these talks should be made, really, in the sense that I'll start by speaking about myself, who I am, where I come from, where my career started from, and then I'll tell you where I'm at now, the research I do right now, and then we'll have a glimpse into this journey into 2034, okay? And I do also realize that you are at your first year of study, and some of the things maybe that will be spoken this afternoon are not really directly applicable. I would like you to still listen and be aware of it. And, you know, when one day, not really even one day, start applying it in your personal space, in your personal situation, even if you are not there yet. Maybe just in little bits, just take bite sizes into applying the message I would like to leave with you this afternoon in your own life and into your own career trajectory. So this is my email address. Let me just get a pointer. This is my email address. I'd like you to please take it down. And if you'd like to talk to me more about the topic I'm going to touch on this afternoon, maybe I didn't explain this afternoon in a way that convinced you, or in a way that you could grasp, just drop me a line and let's have an out-of-line discussion. You know, let's have that one-to-one interaction, which is also good. I love that with young people. I love having these personal engagements with them. Okay. So as I said, who am I? Who is Patience? You know, let's just get acquainted. And I'll use a lot of pictures as well. And, you know, some of the details, maybe I'm giving too much information, just bear with me. It's because I'm also trying to show you, as Yancy said at the beginning of the program, that we might seem like we are successful and maybe we are super people, but when you listen to my story, you'll pick up a lot of common ground between yourself and myself. And by that, I'm trying to show you that you don't have to be a special person to be an achiever or to be a successful individual. You can just be yourself. You can just be from the background you're from and still, you know, in a way, because you are working hard and you're applying yourself, manage to, you know, get to a very successful spot in your life. So who am I? So this is me when I was 6 months, and this is my mother. And I'm zooming into my mother because my mother brought me up as a single parent. Yes, I was born from a mother and a father, but the person who actually was hands-on in my bringing up was my mother. So my mother brought me up as a single parent, and she used a lot of help from her siblings, my aunts and my uncles, and my grandmother actually played that mother role in my life. When I was growing up, I actually viewed my mother as the Minister of Finance, because my mother, the person who was hands-on really in making me my lunch boxes, making sure that I went to school, making sure that I was happy and I was catered for as a child, as a baby, was my mother's mother, my grandmother. So, you know, I love my mother to bits, but my grandmother became my mother. And I'm sure some of you may have that scenario for yourselves as well. Growing up, I attended government schools. So primary school, high school, I attended government schools. And I must say, at the time, 30% was not pass rate, okay? So we actually had very good schooling. Yes, it was in the township. Yes, it was in government schools, but our teachers really, really took their time in ensuring that the quality of education and the quality of our marks was that of a good quality. And in 1994, I matriculated, and I matriculated in a school that was called Riashuma High School. I'm zooming into Riashuma because Riashuma, we were the first matriculants in 1994. How they constructed the school was that they started off with just a class of grade 8. You would say grade 8 nowadays, but it was standard 6 at the time. That was followed by a class of grade 9 and 8, and they grew with us like that. So I was in their first class of grade 8. So I grew from grade 8, 9, 10, 11, and 12 with the school. And by the time we got to grade 12, we were so good, and we were supported so much that we had 100% pass rate in 1994 at Riashuma High School. And that's something I'll forever be proud of. Okay, so that was schooling and high schooling. Then I graduated from Riashuma, but I now suddenly didn't have university acceptance. This was now in 1995. One of my teachers, we used to call them SAE, Teacher Mwahi in Riashuma, said to me, "You cannot have an idle year. Not with your brains, not with your talent. So in 1995, you will tutor the grade 12 and the grade 11 mathematics and physics scholars. And then you will also go and register yourself for a year in UNISA. At the time, UNISA was a long-distance education institution, and don't ask me why. Why did he suggest UNISA? Don't ask me why did he even suggest psychology, but I did exactly what he told me, and I don't regret it. So that was my 1995. Now in 1995, because I was not cleverer, you see, I didn't have a mentor when I was in high school, somebody who said, start looking for university places now, start applying for bursaries, etc., etc. That's why I'm saying you guys are actually so fortunate that you're getting exposed to all of these talks and to all of these experts that are also sharing their life experiences with you. So come 1995, I was now looking for university place and really frantically applying. And then I got accepted into 3 institutions. It was at the University of Cape Town, and my mother said, no, that's too far. I need to be able to support you and keep an eye on you, make sure that you are good. And then the second place was Wits. It's not in a manner of priority that I'm mentioning them. I'm just, giving you the story. Wits, my mother said to me, at the time, it was, 1995, 1996, there was a lot of instability. There would be riots and stuff, and Wits would be in the news. And my mother said, no, too much disturbance. You can't go to Wits. Now, I was left with one choice and one choice only, the Randse Afrikaanse Universiteit, RAU, not UJ, RAU. And at RAU, at the time, they were giving the sciences in Afrikaans. I had the first speaker of this session, of this motivational talk, was talking about language barriers. I had to study in Afrikaans. I had to attend lectures in Afrikaans. Some of the textbooks, I still have them. Actually, I don't know if I have any of them here, but in my office, I have some of those textbooks in Afrikaans, and some of the study guides were in Afrikaans. So how I would study literally would be to translate everything from Afrikaans to English. Then I would understand it. But I'm talking to a group of people that could be potentials in solving things like the language barrier. And this is just something I'm throwing out there. If you think about it today, we are learning in English, right? English is the main medium of instruction. And then in the sciences, you will find in the textbooks, many times than not, there's a lot of Latin as well. Now, this becomes a big problem. You heard Professor Mashifana, right? Sorry if I'm saying her last name wrong, but Professor Tebogo said that when she came to study in the city, her biggest challenge was the English, right? Not because she didn't understand it, but because she was not from a primarily English background. You guys are also studying in English and you are being taught in English, and there's nothing wrong with that. But imagine a scenario where children in the future, in the coming 10 years, are to be given the sciences, good quality sciences, but in their own mother tongue, in isiZulu, in isiPedi, in whatever mother tongue. I leave it in your hands, okay? It's a big ask, but it's not impossible. Just think about it. It might make a lot of people's lives easier. I'm not doing away with English or Latin or whatever, but I'm just merely creating a scenario where we can actually start to appreciate and understand what can be made possible going forward in future. All right, so that was RAU. So I studied at RAU from my first degree up until I graduated in my master's, with my master's degree. And then I got employment at the National Institution for Communicable Diseases. There at the National Institute for Communicable Diseases, I was doing my research in HIV, and I opted to do research in HIV because at the time, HIV was like the biggest problem. Most of the people I graduated with in high school passed away because of the problem, the nightmare that was HIV, and I wanted to be part of the scientists that's now bringing the solution to this monster, okay? And I mean, HIV is no longer that much of a threat. If you are on an ARV program that's reliable and you are sticking to it, people are living normal lives with HIV nowadays, but that was not the case at the time I was now working at the NICD. So at the NICD, my only frustration was that after having graduated with a degree, a master's degree, my employment there, due to the structure at the time, I'm not sure now, was such that I have part-time employment, and if the institution had money to keep me the following year, they would keep me, but there was no guarantee. So I was looking for stability. That's when I started looking for a job, and I got a job at the CSIR, which is where I'm based now since 2004. And then at the CSIR, when I joined in as a medical biochemist because when I was at the second year of university, I was doing physics and I was doing chemistry, zoology and botany. And I remember an incident in class where I was asking a question in the physics class, and my lecturer told me that Black people cannot see in 3 dimensions. I'm wasting my time in trying to understand physics. I'm wasting my mother's money. I should just try something easier. And at the end of that semester, I deregistered physics. So I just decided, okay, maybe I'll just do things that I can understand. Because, when you're young at that age, you are impressionable, and whatever people say to you sticks, and sometimes it becomes who you are. Fast forward, I then graduate with medical biochemistry at master's level, but then I joined the CSIR, and as soon as I joined the CSIR, I get challenged to start a Biophotonics laboratory. And that requires a PhD in physics. And it was explained to me very nicely during the interview that if I was interested in taking up this job as a biochemist, I would be supported to then come on board with my physics, and then I would start this biophotonics laboratory that requires both biology, physics, and other disciplines. Really, it's multidisciplinary. And that's how I got to learn of the University of St. Andrews, where my supervisor was based at the time. It was in the east of northeast of Edinburgh. And, it was a university town, very old university, and it was a beautiful time. And really, when I was overseas, I learned so much about myself. I got to appreciate so much about this country, South Africa. I got to also understand so many societal ills that our country had, in as much as I got to appreciate and celebrate it. And, that really opened my mind. So, as a young person, if an opportunity comes for you to travel and to study abroad, please embrace it. And this is St. Andrews. On a good day, you would be able to see the beautiful small town and take pictures that are not cloudy. And yeah, this is also called the golf town. And in summer, like during June, July, you would meet the likes of Tiger Woods and the other famous golfers, because they would come and play golf in St. Andrews, because it was also called the home of golf. Actually, it is the home of golf. So you get to meet the famous people. In 2010, I graduated with a PhD in physics, not even from South Africa, after having been told previously that I will not be able to understand physics. Okay, so don't listen to negative voices. Okay, we'll get to that also later in my speech, or in this talk that I'm sharing. And yeah, I took my mother with me for my graduation, because my grandmother was unfortunately at the time late. So I took my mother, and she's the only person I could afford to fly over. And I mean, it's an experience she'll never forget, because now she's been overseas as well. It was snowing, never mind my skimpy outfit. That is real snow, but it was precious. So I just had to pose for it. Okay, so I came back now. I started the Biophotonics facility at the CSIR, and we started off with 2 laboratories, and I expanded. We are now 4 big laboratories, and the facility is such that it allows multidisciplinary research. So we've got a cell culture lab, we've got optics labs, and this was my first group of students and scientists. And we attended the 2017 SPIE Photonics West Conference. We do a lot of international conferences. And yeah, I mean, I also became a TED Fellow, and I've done a lot of interviews. You know, I love talking about science and simplifying it, talking about science in a manner that the general public will understand it. So that's why I did TED, and that's why I do a lot of interviews. And I also love engaging young people. As I said, I come from Soweto, so because of that, I do a lot of you know, school visits and outreaches at schools. I no longer have the time to tutor as I used to before I had a family, but you know, I still support and I still recommend tutors for especially mathematics and physics, because I do realize that our teachers do need that type of support. And if as scientists we can really get time to support them, we should do that. So, and I'm also now throwing this back to you as a first year student. I'm not saying maybe do it now, but in your first 3 years of university, are you able to help the community you come from by maybe, you know, giving them holiday classes, whatever, in maths and physics? I'm just putting it out there. I'm not saying go and do it and not focus on your studies. Do what is possible on your side. But, you know, don't just focus on developing yourself, focus on developing with others. So the reason I'm showing this picture is because this is a school in Soweto, Mdeni, in one of the townships here in South Africa. And Mdeni, the government, our government, so graciously built a school of specialization. And the school of specialization honored me for my contribution. It was actually the Department of Basic Education that honored me by putting this portrait of mine on their science block. So this is a very big picture on a block of science in a school, in a physical school. What an honor. I mean, when I work, I don't work to be given acknowledgement or to get recognition, but, you know, there are people that are watching and they will appreciate. So this was one of the appreciations. There's a lot of highlights as well. You know, this was the most recent one, the NSTF one. Last year, I got the highest category, distinguished researcher woman researcher in SAWISA. And I've gotten an award from the president and, you know, various other awards. But this is my team, and I don't only get awards. My team also gets awards. So I'm just sharing some of the highlights from the team as well. Remember, I was told I couldn't do physics. These are both my PhD students who graduated with their PhDs in physics. So not only did I get a PhD in physics, but now I'm producing PhDs in physics. There's another PhD in physics. There's various other ones. It's just that I don't have space to share all of them. But these are some more of my you know, current students that are getting awards on different platforms, you know, best oral presentation, best poster presentation. Why am I showing this? I'm trying to say wherever you can also be of contribution to lift another, do the same. Don't just focus on yourself. And also, I'll repeat it, do it as far as it is possible on your end. Don't try and put pressure on yourself. You still have a lot of time. Okay, so outside of the lab, and I want to check my time because I don't want to.
You still have 5 minutes.
5 minutes, sure. So, okay, outside of the lab, I am a wife and I am a mother of twins. Yeah. And I want to talk particularly about this picture because grief is something that affects and impacts us all. You know, this was my sister. And in 2018, I gave birth to my beautiful twin boys. But on the same year, before they even turned a full 3 months, my sister passed away. And, you know, I'm sharing this because that really left a void. I'm still struggling to get past it. So why am I sharing this? I know that grief could also be part of your lives. And sometimes you don't even know if it's normal to feel the way you do because of grief. It is normal. And can you still be successful? Of course you can. You just need to get the necessary support and be able to deal with it. That's my only sister from my mother's side. So my father had various other kids, but my mother only had me and her. And when she passed away, I felt like, you know, she also took me with. But I'm enjoying and I'm making sure that I'm also delivering as much as I need to. Okay, life at work. What do I do? So right now I'm based at the CSIR. It's been said. I'll go quickly now because I realize that I don't have much more time. And this is the CSIR campus. There's a lot of beautiful research happening within the CSIR. You heard Prof Igle Gledhill mention the mission statement of the CSIR, and I think you want to be part of that. I'm not trying to market the CSIR, but I'm trying to say to you, consider also coming to campuses, science councils like the CSIR, where there's so much in terms of research that you can explore. Part of the reasons why we were asked to give these talks are to also throw to you possible career possibilities that are out there. And the CSIR is one such site. You can really see the types of career directions you can actually take. Okay, I am based at the Photonics Center within the CSIR, and this is all the research that happens there. This is my group, and what we do is we are developing diagnostics that are based on photonics, okay? These need to be portable, they need to be low cost, and they need to be applicable at point of care. Biophotonics really mixes physics as well as biology. It's actually physics being used to solve biology problems. You heard Professor Gledhill also mentioned Newton's laws on how to understand glutamine synthetase, remember? So I usually say to my kids, they are just 6, I usually tell them physics is all around you. And they ask, Mommy, what is physics? And then I try to explain what physics is, but physics truly is all around you. You can use physics to understand various things. So right now you are learning about those Newton's first laws and you are learning the fundamentals and all of that in physics. Don't take it for granted. You might not understand the overall role of it now, but later you can use those same equations to solve real life problems. So as I said, we are multidisciplinary. We are photonics, but we understand the pathogens like your HIV, TB, COVID, and then we also understand what causes things like your hypertension as well as your diabetes, which are non-communicable diseases, but we also want to play in the space of making medical devices, which is something that is not happening at the rate it's supposed to be happening in the country right now. Okay, we are importing a lot of our medical devices. Can we actually make and then export? It's something we are trying to answer. So the work that I do has applications in health in the sense that, you know, when we are in cities, like right now I'm in Pretoria, if I'm sick, I'll go to my doctor will recommend a few blood tests and my blood tests will be taken to a lab like this, where there's a lab technician and it's fully resourced and the technician will be able to in a few days, send my results back to my doctor. These guys in rural KZN don't have that luxury. So what are we doing with the work that I do is that we are putting the laboratory that you saw in the picture previously into a smartphone. This smartphone can then be used as a laboratory for a person in any place where they are based in South Africa, and help them to do diagnostics. So that's one of the things. I'm showing this picture because it's one of those technologies that we are really trying to get to the market right now. And then the work has got also applications in pharmaceuticals, in the sense that, the WHO, which is the World Health Organization, tells us that 1 in 10 medical products in developing countries, and South Africa is those developing countries, one of those developing countries, is substandard or falsified. We are using photonics to do bulk screening of medications as they come to the country before they get dispatched to the populations. Another problem is where you have medications that are not of good quality because they've been stored incorrectly. Our photonics technology can inform us as to whether that's the case or not. And because I'm also using foresight to sort of like really think, and this is where we are going now with this journey into 10 years, in the coming 10 years. You need to think about where you are right now, but not only that, where will you be in 10 years? Where will your work be in 10 years? And then I spotted an opportunity in applications in agriculture, because people will always need food. Right now, our country has been having challenges with load shedding, and with load shedding comes problems with water. Okay, and problems with water then lead to what? Problems with lack of food, maybe food safety, food security, and all of that. That's where we are now starting to apply our work, so that come time where there's maybe really a problem, photonics is also applied in food. The other one is beauty. People are big into aesthetics right now. So that's where the trajectory is moving towards. Okay, but let's now get into this future back thinking. And now I'm out of time. But I'll be quick about this. What is the future back theory? You might have not heard about this before. You may have heard about it before. It's applied mainly in organizations, but who said what's applied in big organizations cannot be drawn down to an individual, right? An individual should still have their own mission statement, their own vision, their own values, whatever the case, right? So just like big organizations, we need to start applying ourselves in this type of theory where we are doing future-based thinking. And what is this really? Future-based theory is, you have a vision that's readily to be translated into a future-back strategy. So you may have a vision that you're applying in the present day, but it should come back and be your future strategy. And what happens is that you have two scenarios. So you've got attributes of the present forward thinking, which is high in knowledge, and it is based on what is known, right? It is based on rules, on facts, on data. And then you've got the future back thinking, this side now of the picture, where it is high in assumption, okay? So it's very low in knowledge, it's high in assumption, and its aim is to discover what could be true. And its aim is to discover what is the strategy that needs to be put in place to be successful in the future. Just, superficially, topically, I'm explaining it, okay? So if you look at this World Economic Forum report, it tells you on how to prepare for the future. And they state 10 skills here, okay? And you can see that all of these really apply, and they exist in the sciences. When you are in the field of STEM, you will definitely come across all these steps. But then it comes to self. If you are taking a journey into the coming 10 years, the first thing you need to have is a navigation system. Did you know that all 20 of you have got an inbuilt GPS? What am I talking about? I'm talking about that still small voice within you, not the voices, not the noise outside. Zoom into the signal, right? And that signal is that still small voice. That's sort of your navigation system. This is the voice that will tell you what your purpose is. Why were you created? Okay. And once you've heard what your purpose is, you will know who you are. You are not the course that you are studying, right? And you are not the vocation that you will be working in one day. You are your purpose. The reason you exist is because of the purpose you were created for. And you will not know your purpose unless you know how to keep quiet and listen to that navigation system that's inbuilt, that's in you, okay? You can listen to a number of excellent speakers and all of that. Your role model number one is yourself. It is that voice. What is it saying? Where is it taking? Where should you be? Okay? Because it will tell you, if you are in a pub during the time to study, that voice will tell you. Okay, that's your biggest mentor. It will tell you, yes, maybe you will ignore it because you don't want to hear it. But if you're doing something you're not supposed to do, the navigation system will tell you. So the second thing is, if you are preparing for this journey into the coming 10 years, do the research, okay? Will having a PhD in 2034 still be relevant? I'm not saying it's not going to be, but just picture it and do research. And if it is still going to be relevant, in what field really is it going to be still applicable and relevant? You want to think about that, okay? And then put the plan in writing. Have a manifesto. You'll see political parties have manifestos. What's your manifesto? Your leadership manifesto, Prof. The Prof that spoke before, the previous speaker spoke about leadership. Okay, and why you guys need to think about leadership and start thinking like leaders. Have a leadership manifesto. What's your leadership manifesto in the coming 5 years, in the coming 10 years? Say it, mention it to a mentor. The speaker before me spoke about mentors. Mention your leadership manifesto to your mentors and tell them what you want to do in future. The reason why it helps to put it in writing is that it helps you to also achieve it. Anything that's in writing is a constant reminder that, no, this is where I'm going. Once the GPS has now, show you the navigation, you've done the research, this is where you are leading towards. Very importantly, be multidisciplinary, be multidimensional, okay? Do not fixate yourself. I'm a physicist. No. The innovation nowadays, it will not allow you to think like that anymore. Nowadays, you need to be interdisciplinary. You need to speak to social scientists. You need to speak to politicians. If you are in your first year, you don't need to necessarily just be friends with the scientists, the natural scientists. Get a friend in sociology. Get a friend in politics, in various other things. Because you know why? Come 10 years' time, you need, as a scientist, to speak to policymakers. If you don't understand how policymakers think and do things, how will you be able to engage them? The previous speaker said you must be able to learn outside of your discipline. This is how you learn outside of your discipline. You network, you collaborate, okay? So please, let's stop being in silos to say, I'm a physicist. Our universities should also allow multidisciplinary courses, multidisciplinary research. And this is one of the things that is my drive right now. I would like to see that. I would like to see biophotonics as a standalone discipline in a university. Okay, I know, Hansi, I'm about to finish. And then continuous scanning of the horizon. Okay, you need to, I know you're young, I know you're in your first year, but you need to continuously scan the horizon. How do politics look in South Africa today? How will politics look in South Africa in 10 years? Are we still going to be a democratic country? I'm not saying we are not, but these are the things you need to think about. How is our economy going to look like next 10 years? What is geopolitics saying? What are neighboring countries doing? All of that, okay? And then just nuggets from me and in the STEM field. And I know you guys might still be, at junior level, but never allow anyone to define your limits, okay? Only you know how far you can stretch and how high you can bounce. Develop a good relationship, okay? Your relationships will carry you for the rest of your life. The people you know now might, go separate places, but I've learned that in STEM, goodbyes are just temporary. It's not forever. Help come from unexpected places. Always keep an open mind. And, in STEM, there's nothing like a glass ceiling. I do not know a glass ceiling because I just stretch myself. Thank you. Sorry, Yancy. Sorry. I longer than I was supposed to.
Thank you very much, Prof Mthunzi-Kufa, for making the time and giving us this wonderful presentation while you're not feeling well. And my condolences on the passing of your sister. Yes, indeed, life happens, and it can throw one very badly. But I am full of admiration that you continue and you do such wonderful work. Thank you very much indeed.
Thank you.
Our next speaker is Prof Nozipho Nyakale. She is chairperson of the board of directors of NuMeRI, the Nuclear Medicine Research Infrastructure. And she is representing NuMeRI today because NuMeRI won the Innovation Award for a corporate organization at the NSTF-South32 Awards. Welcome, Prof Nyakale.
Hi, Yancy. She joined and then fell off.
Oh, did she? Okay.
Yeah.
All right.
And a few minutes ago, she did say that she was struggling with connectivity.
Oh, okay. All right. Any questions for Prof Mthunzi then? Zinhle? No? Prof Mthunzi, I want to just also say that I'm impressed that you studied at Rao and that you had to study in Afrikaans and you managed to do it. And at that stage, the university wasn't very much transformed. So it's really quite a feat that you managed to study there and make a success of it. I also studied at Rao much earlier than you. In 80, well, when was it? 1979. Showing my age. But even then, there were a lot of study notes in Afrikaans, but our textbooks were in English. We all had to become very proficient in translating, you know, from your Afrikaans
English to Afrikaans. Yeah.
Yes.
Yeah.
To the English, in which you really had to function academically and then translate back in Afrikaans so you can do your task, your assignments.
Yeah. Yeah.
So, but it's a good thing about South Africa that we have this multicultural environment in which we have to function.
Exactly. Yes. And you know, Ansi, sorry to just jump in and not to come into you know, into your mouth while you're speaking, but I must say the Rao experience was actually one experience that I value with my life. Because not only did it expose me to the language, I mean, my Afrikaans is pretty fair, you know, I can speak, write, and read in Afrikaans without a problem, you know, and if I really listen to myself, I can speak beautiful Afrikaans. It's an empowerment, and it's something I'm teaching to my children right now. I would never do away with any language or any culture, because these are the experiences that shape us.
Yeah. Indeed. They definitely are. Thank you. Any questions? Students, must I call on you one by one? Any comments or questions at this stage?
Am I audible?
Yes.
Yeah, I have a question. So we're in a world where information is readily available. So is there any benefit or use in pursuing a postgrad if I can just study the stuff on my own instead of just pumping out my own resources to do a postgrad?
Okay, that's a good question.
Sorry, Auntie, I didn't get the question nicely. Can you repeat it for me?
Yes, he says that is there any point in doing postgraduate research, postgraduate studies, in a world where you have all the information basically available?
So remember, even from the previous speaker, he said you must, okay, let me first answer it like this. I would never stop learning just because there is an opportunity to have AI do my work in the future. Okay, learning is self-empowerment. So you need learning in your life, whether there's, an additional aid that you can get from the internet or whatever. You need self-empowerment because it also sharpens how you think. You can't just do away with postgraduate learning just because we are in the fourth industrial revolution, or maybe, in the coming 10 years, it will be the fifth or the sixth industrial revolution. You still need your learning, okay? Because it's a self-investment that you will cherish forever and that you will forever need. So that's how I would answer that question. But also just, reverting back to what the previous speaker said, you must learn, and you must learn, outside of boundaries. Just be a person that's open-minded and that's absorbing. You will not be an expert in everything, but it's very good to be knowledgeable because you can take up a discussion with anyone and everyone.
Thank you for that. Would any of the other speakers like to answer that question? What is the point of doing postgraduate studies?
Well,
Yes.
I think it's really important because even in my context, though I'm not a researcher, I mentioned that I run a data science team, and those people have to build products that inform decision making. So you can't really appoint somebody who doesn't know what they're doing just because they have the technical skills. That background knowledge and expertise is still required, regardless of whether we're in the fourth IR. So yeah, I think from that perspective, it's still important. And yeah, it's just be curious and keep learning.
Yeah. Thank you very much for that. I think I would respond that it's about integrating knowledge in a unique way. I mean, all of the speakers who have spoken today have spoken about the multidisciplinary fields and about taking knowledge from all over and integrating it to solve problems. So I think you can only do that by training your mind to think in a particular way. And that's why you need postgraduate studies that will train your mind. Would you agree? Okay. Thank you very much for that question, Ria, and for the responses. Any other questions? This stage? Kamani?
Hi.
Hi.
I wanted to ask the speakers on how they will advise one to take on interdisciplinary learning.
That's quite a difficult question. Having spoken about the virtues of interdisciplinary learning, how do you actually do that as an undergraduate student?
I think depending, I can start.
Sure.
Depending on the program you're in, there might be a lot of flexibility to take courses that are unrelated to your area of specialization. For example, when I was doing a BSc, you could take, they would prescribe maybe 2 or 3 courses, and then you find that there's allowance to take a fourth one that's completely unrelated to that. So I think that's one way to start. But I think engaging with people you meet along the way is also a nice way of exploring things. Because, for example, before I started working, I had no idea that one could be a data scientist, one could be, you know, a systems developer, systems architect, because I had never been exposed to that kind of environment. So be curious and everything will fall into place.
Thank you very much, Mr. Chiloane. Prof Mthunzi?
Yeah, so Yancy, at undergraduate level, it might be a bit of a challenge. So if I was a BSc student now, right? And I know it might be a little bit difficult because this is not something you necessarily plan for, but I would be intentional about making sure that I'm not only sticking to the straight and narrow as per my program requirements, but I also poke my nose into other areas. Like, as I was saying when I was speaking, befriend somebody in the social sciences. And just, even if you are not formally doing sociology or politics or, you know, the other social sciences, but just have a discussion with, you know, your peers and see what are they studying and doing in their space. And equally so, share your sciences with them, because it also helps you to understand more what you are doing in the sciences, and also, you know, creating an awareness to a person that might not necessarily be a scientist, you know. So it's just sharing at this stage. You can take it, you know, small doses, you know, bite sizes. You don't have to go all full on. Now you're doing a sociology and a psychology course and this and that. No, just discussions with those that are not necessarily in your field, and reading, you know, just pick up a book. You know, some books are specific to a specific discipline, but you might not necessarily be studying that formally. You know, just pick up a book in sociology, pick up a book in economics, pick up a book, you know, there's so much that you can do. And nowadays there's also social media that will allow you to do it quicker than maybe reading it in a book. I'm not advising that people should necessarily, you know, be pursuing social media for that. But, you know, I'm just putting out different scenarios and options that might allow you to be open-minded and to tackle things that are not necessarily only in your field. So yes, stick to your field, stick to the program in your field. You are in your first year. You don't want to be all over the place, but you also don't want to, you know, make yourself, build a stumbling block for yourself to say, I'm just going to focus on the sciences. Just, you know, have a coffee with somebody that just came back from a psychology class.
I like that. I like that very much. And it's, you might not appreciate it while you're at varsity, but as you hear from these very professional people who have achieved expertise, it is really a part of the working environment of a scientist to deal with all kinds of people with different kinds of expertise. And that is the way in which you actually solve problems, is having a coffee outside of the box, if I could put it that way. Thank you very much for that advice. Itumeleng is, are we able to move on?
Yes, she's in Zoom, Prof Nyakale.
Oh, is she? Okay. Thank you very much. Okay, Prof Nyakale, welcome. And please do go ahead with your presentation.
Thank you very much. Can you hear me?
Yes, I can hear you.
All right, I'm just gonna open my video just to say hello. I'm in the car because I couldn't get, or you can't even see me. I couldn't get proper reception where I was, but that's me. So let me share my presentation. Good morning. Is it still morning? Good afternoon, everybody.
Afternoon.
All right, let me start at the beginning. I'm just gonna give it's the what do you call it? The mandate was, it must just be, I try to keep it simple and just motivate our wonderful students. Can you see the presentation?
Yes, I can see it clearly.
All right, okay. All right, thank you very much for having me. I hope I'll be able to inspire the students. I was looking on your site and I was quite impressed with the students that you have. And I think, yeah, the world is looking great, especially South Africa. So just to introduce myself briefly, I'm a nuclear physician. I don't know if you, I'm sure you've, I don't know if the students have had a look at the bio. I just tried to keep it brief, but I have headed a few departments. My initial in Gledhill, where I stay now again, but now I practice. And then the other department that I headed for nuclear medicine was in Makhato Health Sciences University. I'm the board chair of Numeri. So just to get going, I just thought, let me just maybe just tell you my journey. I hope, can you hear me? I see it says my internet is unstable. I hope we managed to get through this, but I'll try and keep it brief.
I can
So
hear
I
you
just thought I'm
clearly
just going to
now.
talk you through. Oh,
Yeah.
okay, I hope the students can too. Thank you very much. I'll just keep it, my journey. And I think just to start, I think we tend to try to plan our career. I remember when I was like, and well, I never really, so we used to have what we call career guidance class. And I must say, I don't even remember.
Oh dear, I think Prof Nyakale has fallen off. Sure. Connectivity. There she's back again. Prof Nyakale, you fell off briefly. Prof Nyakale, are you there? You are muted at the moment. I think connectivity is quite a problem.
It's very bad on my side. Okay.
Yes.
I've tried to reconnect with another device. Hopefully that'll help me.
Okay, fantastic.
Okay, let's try again. So I don't know if I should start at the beginning, but anyway, what I was saying was normally we try to plan our careers and we try to start when we were young. And the beauty of today is that our students get to have access to everything. The world is just a click away, a computer away, internet away. So you get to know what is out there, what your options are. But when I was young, when I was growing up, the only thing I've ever wanted to be was a doctor. So I was going to be a doctor, and then everything. That's why I say I attended career guidance, but I don't think I ever heard anything because I was going to be a doctor. But I thought it was going to be easy. I was just going to go to school and then end up being a doctor. And I remember at some point I thought I'm not going to stay in clinical medicine too long. I'm going to be a researcher. I don't even know what I knew about that at the time. But then I thought the journey was going to be a straight line, like the first image there. But it turned out to be quite a different story. So when I was born in the in 1975, so I'm quite almost a golden oldie now. But from a very young age, I knew I was going to be a doctor. But what happened was in matric, I didn't get the marks that I wanted. So I didn't make it into medicine. So what I did was I ended up doing a BSc, a Bachelor of Science. I then majored in psychology and biology because I just really liked the health sciences, all that stuff. So right now I'm here, and despite the fact that it took me so long to become a doctor, I still managed. So I did the BSc, and after the BSc, I then ended up getting into medicine after the 3 years of doing my BSc. So it took me 9 years to just become a doctor. And then once I became a doctor, I realized that it can't be the end of the journey. So now I'm a medical doctor. Now what? I did all the stuff that I needed to do, but ended up I think for a second I liked pediatrics. I think it's very typical of women, many women to go in that direction. But I was one of those. I like kids. I forgot to mention that during my medical school journey, in my 5th year, I then had a baby. And then when I had my child, when I did pediatrics, because I thought I was going to be a pediatrician, whenever I would rotate in the pediatric blocks, it would be such a painful thing for me. I would personalize it very much. So that became a thing that I wasn't sure I was going to do. I still tried to follow, but I didn't. And then one day I was at a meeting. It was a what we call M&M. It's like morbidity mortality meeting. A patient had died while I was on call, and I was being questioned. I was still an internship. I was a little girl, and I was being questioned as to why this happened and so on. And then somebody mentioned, did you do a thyroid scan? Did you do this scan? And I realized, oh, okay, let me go to the library. Let me go find out what that is about. And then I went and I found out that, oh, there's this beautiful field called nuclear medicine. And then that's exactly what I did. I looked into it. I thought, oh, what a fascinating thing. It's got physics. It's got all these things. This is me who couldn't even get into medicine. But I still wanted to do physics, and I wanted to do all these fancy things that came with nuclear medicine, radiopharmacy, all these things. So I still did it. And essentially, I'm trying to tell you guys that your dream doesn't stop. You just decide whether you're going to stop it or not. So it took me a while, and I eventually became a nuclear physician. But from the moment I qualified, I feel like my journey just, the journey went faster to make up for the time that I had taken so long to actually get there, because I had to do a BSc, unlike you guys who are very clever there, who could just go directly into whatever field you want to go into. So that's how I became a nuclear physician. So my superpower is that I'm a nuclear medicine specialist.
Wonderful. Prof Nyakale, can
Yes.
I interrupt you? We can't see your slides. I don't know if you are sharing them.
I am. Oh my word. Okay.
Oh gosh.
Oh, you shame, guys. I'm so sorry. I'm ruining you.
No problem.
All
It's a
right,
very interesting story. It's fascinating.
Okay.
But it's
Okay,
at
let
the
me
bottom
try
of the
again.
Zoom screen is share screen. And then you have to click
Yeah.
on your presentation and click share again.
Yeah, I had done it, but I see it just disappeared. But let's do it again.
Okay. Yes.
Are you
There
seeing
it
it now?
Yes, there it is. Yeah.
Okay. All right. Okay, I'll just show you the slides, but I won't speak much because
Yes.
I've already said it. It's only 2 slides. So I just want to remove this so that, okay. So this was the first one, and then I was just talking about career plan and just explaining to you that this is me at this stage of life. I've only got I've got my last quarter left, yeah. And then this is where I ended up. So I became a doctor and then a nuclear physician. And now this is what I was saying, that now I'm a nuclear medicine physician. And I feel like from this stage, that's where my life started my journey started to go fast. So just to quickly tell you what nuclear medicine is about. So for those who don't know, I'm sure you have an idea. But generally when I tell people that I'm a nuclear physician, they always ask me what I do. So I always start this way. But what we do is that we take a certain isotope, meaning a radioactive element, and then we bind it to a drug, very small doses of drug, which will help us to see certain functions in the body. So whatever we bind it to, it will go to the part of the body that we want to see. So it's called targeted imaging. And by doing this, we're able to also take an isotope, a radioactive substance that is very detrimental to the cell. So because it's gonna destroy the cell, then we can bind it to a similar drug that's gonna go to the cell that we want to kill. So we're able to use that for targeted therapy. We call that theranostics. Some say theragnostics. So you see what you treat. So we image, and then with the same drug, but using a different radioactive substance, we're able to then treat. And then our field is relatively new. It was only started in the 80s or so. It's very, very new. So there's a lot of research going on. There's a lot that is being discovered, and medicine is growing in all fields actually, and it's becoming so targeted that I think for patients to get what do you call this, toxic effects is going to get less and less with the different treatments. So there's it's an ongoing scientific experience that's just carrying on. These are some of the equipment that we use in nuclear medicine. And then the staff consists of the specialists, radiopharmacists, medical physicists, radiographers, nurses, and of course the rest of the support staff. So it's quite an interesting field. So this is me on my first day. I got to the department. It was back in the day before it got so advanced. Now the images look much better, and I'll show you just a little bit. So I just saw this is what we call it's to track the lymphatic tract to see if they're working or not. I remember seeing a scan like this and I'm thinking, this is just dots. What am I going to do with my little brain? Am I ever going to be able to understand this? But it became such a passion for me, something that I really loved and I started to understand. So what actually happens once you qualify to become a nuclear physician, you can either go get a post in the state sector, which is what I did, go to private, or else you can do anything else. Similarly, with any study that whatever field you have chosen, I think you can become whatever you want to do. I heard as I was entering the session that one of the students was asking how you can collaborate with people. But I think it sounds harder than it is. I think we're in an age, I remember hearing something, it was just one of these motivational things, and they were saying, you must try each day, if not each week, to have lunch with someone new, someone that you don't know. So, I mean, you're going to have lunch anyway. Find people that are in a similar space as you, similar likes that you speak to, and you'll find people who may have a different direction, but looking at the same similar topic to you, especially these scientific meetings that we're attending, all these things, you'd run into so many different people in different careers that have similar interests, and you can collaborate with them. So, there are many ways to go. So in our field, we call the nuclear medicine specialists consultants. So you can either become a progressive consultant who will keep going, keep moving, collaborate, do research, do more service-related things, or you can just become somebody who just sits around and just reports scans. But I think it depends on the individual which way you're going to go. They say dreams are made by people around you, but actually you're the one who determines your direction in many ways. So the challenges with our fraternity is that it's a relatively new field, so it's misunderstood, not well understood, and it used to be regarded as unclear as the picture that I showed you. But then we've progressed so much that we do what we call hybrid imaging. So we're able to link the anatomical scans with our functional scans, and we are able to see where the issues are. We call these are PET scans, but we've also got SPECT scans and all that stuff. So we look at the function in the body. So now as a nuclear medicine physician, as much as I'm saying all you do is look at the images and you report, because it's such a new field, you end up becoming a jack of all trades. You wear many different hats. You're a pioneer because you start new therapies through research and all that. We advocate for health with diagnosis and treatment. You're a salesperson, a marketer, because you have to tell people about your field, tell them what you do, how it works. Even the clinical doctors, I mean, even in undergraduate medicine, I didn't know anything about nuclear medicine. I knew very little. So they don't even teach it in undergrad. So you sort of have to find it out. You're an educator, you're an author, advisor, manager, radiation officer, you're everything in one person. So as I was explaining that, so I qualified in Steve Biko Academic in University of Pretoria for nuclear medicine. And then once I was done there, I stayed. I got a job. I was working with Professor Satehe. He was actually supposed to give this talk. So I hope I do justice to it. So he's quite a force in South Africa, as you know, I'm sure. So I stayed there for a very short time. I worked after I qualified for maybe less than 4 years. And then I decided I want to grow. So I moved to UKZN, to Natal, to Nkosi Albert Luthuli Hospital. At the time, nuclear medicine was not yet registered as a qualification in the university. So I worked on getting that going. So I was running that department. I was head of unit, but I was running the department because there was nobody above me at the time. So I became an instant boss. No teaching on how to become that, what to do, and so on. So essentially, I had to learn on the job. And because you have to be passionate with the positions that you're put in, I think you learn as you grow. So in your career, you must remember. I remember thinking to myself that why would somebody like, because my voice is very soft and I'm a short. If you see me, it's just that it's not a. I wish it was a face to face, but I'm a tiny little girl. Well, not girl anymore, woman, soft spoken and so on. So I was wondering how would God put me here? So because honestly, there is no way. But I got there and I just told myself that nothing is impossible. So I pushed and we got so many things going. We got therapies from nuclear medicine. We got so many things going. So it became a very flourishing department. But then life had its own plan. So I ended up going back, joining another university because I'm actually originally from Pretoria. So your role as a leader in nuclear medicine, I've already mentioned some of the things that you have to do, but then because it's such a new and ever-changing field, it becomes very challenging, and you tend to have to navigate the space yourself, find a way to you end up with an identity crisis because you're supposed to be a teacher because you've got registrars to teach, a researcher, a clinician at the same time, a businesswoman as well. And I'll tell you some of the things that I did during that time. And then in academia, you also have to do a lot. You teach, you attend to service, and that on its own implies quite a lot of things. And then there's also community engagement, and you also have to learn to collaborate a lot and make sure that you also get funding, all that stuff. So it's quite a journey. And I think the important thing to do as you grow in your career, Google a CV of someone that you think you look up to in your field and see what they have done. And then look at academic promotion documents from your university. If you're in a university, I know you guys are still young and you're still undergraduate, but just think about it already. Identify a mentor, somebody that you feel like you want to model, that can help you to get to where you're going. It's good to plan. It's good to have timelines. It's good to know what actual niche you want to find yourself in. But the thing is, sometimes those plans don't work out, and you cannot be dissuaded in any way. But remember that you're not a one-trick pony. You can actually wear many hats. So for being a woman, I didn't want to address this to women because I know we've got gentlemen there. But you have even extra challenges because even in academia, you find that the men get the funding mostly. If you write articles, their articles tend to get accepted more. So you come with you find that there are many more challenges toward the ladies than the men, but it doesn't mean that you can't get to where you're going. Apologies, I think my phone is ringing. Okay, so beyond joining the state sector, there's also the option of going to private, which is where I am now. So sometimes you find that you thought you were going to be an academic, and then you find that it doesn't really work out. So if that, I call that the blessing of a closed door. So if you find that things don't work out where you are, you can always go and either start a private practice in your line of work, science related things. You can still do that. You can find funding. And there are some unconventional opportunities like what I did. I also joined because I had been involved in so many things, I ended up joining industry, becoming a board member. I was a board member of NTP, which is where we get radioisotopes. I've been a board member of AEC, also one of the producers or the suppliers. And at the moment, I'm a chair of the board of Numeri. So you have to be willing. I don't know, you guys are very young, I know. And there's this other movie, I think it was in 2008. Jim Carrey acted in it. It's called Yes Man. He was a very negative person, and then he attended some conference, and this guy was preaching how he must say yes to everything. And I think this is probably the theme for my life. Because for many times, like there are many times when I would just be asked to do things, and I would say yes, and I'd do them. Well, obviously in the field, and obviously within reason, and obviously it's like this lecture. At the last minute, I was asked, "Can you come and join us?" And I said yes, even though I know I have limited time. I have this, but if I can apply myself and be there, I think try and just make sure that you are open to things, and don't just close your doors yourself just because you don't want to inconvenience yourself, because I do think we need to be a little uncomfortable in our lives for us to progress faster. So your relevance is dependent on the next thing you do. What you've done today, after you get this degree, you've got this funding, you've got this degree. What's next? And every time you achieve something, you have to move on to the next thing. So I think that's exactly what you should look at your life as, because people forget you. You know, you were so great now, and then what that was last year. You got your degree, you graduated. That was last year. What's next? So keep reinventing and moving forward and doing something new. So what are the opportunities in my field? For example, we look at patient-centered care, targeted therapies. There's partnerships with related disciplines. So this is where your collaborations come in. And it doesn't even have to be a collaboration with that particular field that you've chosen. You can collaborate a scientist with a nuclear physician with, there are so many ways there are so many things to be done in the world that it doesn't really take just one field. So this is NUMERI. It's another opportunity that has been there. It's one that, as you can see, they've won the NSTF award there. We won, at least the company. So this is it's called the Nuclear Medicine Research Infrastructure. It's in Pretoria. And this is where medicine essentially is gonna get to heights that we never imagined, especially the nuclear medicine field. There's preclinical work that is going on, research related. There's clinical research that's going on, a lot of PhDs and a lot of qualifications coming out of this infrastructure. And also it's going to be just a force in South Africa to make sure that our country is on the map and is developing, and we can better the health of the world and especially of South Africans. So this is a great institute that has been started. These are the great people that were part of it. Prof Satech is one of them, and Prof Jan Rain. You can see the DST team there as well. So this is what we do in nuclear medicine. We can treat, we can give therapy. The orange lines on the image on the left where we can give therapies, and then the blue lines is just to show that we can image. So we can image and treat. And then the difference between nuclear medicine and normal radiation therapy is that we give targeted therapy. So we give it internally rather than irradiate patients from the outside. And nuclear medicine is the future, of course. And just to show you that if you look at the top picture with the red, it's a patient with prostate cancer who's been treated with the nuclear medicine, what we call PSMA. It's PSMA therapy, usually targeted with either lutetium, it's an alpha emitter or something, or beta emitters, which will then kill the cancer cells. So if you look at the red images is where the cancers were, and then the image next to it is after the treatment was given and the patient has been cured of the prostate cancer. We can treat arthritis, we can treat skin cancers and multiple other things. These are just some of the examples that I thought I would show you. So technology is also improving in terms of AI, telemedicine, and it's important. It's easier to have international partnerships and employment, because now you're not stuck in one place. You don't have to be where you are, and you don't have to necessarily move to new countries to be able to establish anything. So what advice should you ignore when you're starting as a young person? Is that there is no future in your field. Whatever field you choose, there's a future. You don't have to stick to conventional things that people do. You can, in the same field that you're in, decide to just spice it up a little bit and collaborate and just find a different direction in the same field. You don't have to stay where you are. If you're like me, you can move around. I mean, I've moved back and forth. I've headed 2 departments already, and now I'm in private practice. So if you stay in one place, you're not being loyal to yourself. You may be loyal to your boss, but your boss may also decide to just move, you know. So you need to be loyal to yourself and make sure that your career is growing, but in the direction that you want. You must never think that what you're thinking will never work. So whatever research project you want to do, if you investigate it enough and you're passionate enough and you're convicted enough, you can do it. And then try not to tell people your plans, because sometimes it's good because then they expect results. But sometimes it's you know, people may overtake you with your plans. And then what advice can I give you? The future is in science. Know yourself and your values, and just make sure as you grow, you follow those. Run your own race against yourself, because if you're busy trying to imitate your friend, they know what they know. They have resources that they have, whatever they are, whether it's talent, whether it's money, whatever. You cannot compete with somebody else's passion. Yours has to be yours. You must never stop learning. It's important to keep on growing. So your life is you must continue learning right up until the end. So it's a scientific process. Your whole life is a scientific process that needs to grow, that needs to evolve. So connect, collaborate, explore, move, be flexible as much as you can, be fearless, be visible. And you must be a brand, you as an individual. So believe in your dreams and keep on going. And then remember to get mentors, but remember that mentorship is not a one-way street. You can check videos about approaching someone to be your mentor. You can connect with people on LinkedIn and so on, but people don't want people that come to them and say, I want to become a scientist. What must I do? You must come with your plan already in place and just get your mentor to just push you in the right direction or direct you in the right direction. Sometimes mentorship may or may not work, but if you ask the relevant questions and you find the right person for you, it may work. So your role as a young scientist, you need to, for all of you, grow together, network as much as you can. If you're a shy person like me, try to just get out of yourself when you are with people. Try to speak. I think if you speak the same language and you like the same things, you will actually just find a way to have a conversation that will get you forward. Peer mentorship, mentor each other, be inclusive, and don't try and hog everything to yourself, because the more inclusive you are, the more you work with others. And then try and create groups and whatever it is, the field that you're in, you can work as a group together. So this is just to show you that even if you're a different person, whether you're a man in the middle of women or a woman in the middle of men, you can still achieve. Look at this lady here. This is one of the ladies that started nuclear medicine. And she was the only one among all these men received an award for the work that they had done. So you can be whoever you want. And the person that you are at work doesn't have to be necessarily the person. Well, you must obviously be a consistent human being. But I just wanted to show you that you can still live life and you can still be anywhere. You can still do anything. So the work me, the outside me, the home me are 3 completely different people. But at the same time, we are the same people. We look the same, but we're 3 people. But also keep your principle. So that's it from me. I hope I managed to keep to the mandate. I may have drifted off a little bit, but I'm here to answer any questions. Thank you very much.
Perfect. Thank you very much, Prof Nyakale. I love this this brief that you gave about what advice should you ignore. I hope your students are taking note of that, and I think it's echoed in a number of speakers' talks that there is advice that you really should ignore. If anyone tells you you are not capable of perceiving 3D because of your color or gender, then ignore them. They don't know what they're talking about.
They don't. That's absolutely true.
Thank you very much indeed, Prof Nyakale.
Thank you. Thank you so much.
Yes, I think this is very valuable for the students who are studying medicine. Most of them, well, a big group of them are actually studying medicine.
Okay, great.
This is very valuable indeed. We went to see Itemba Labs in Cape Town.
Yes, in Cape Town.
So they got a little bit of an introduction there, although it was quite high level and quite difficult to understand if you're not in the field of nuclear science. So I hope that they will read up further and actually become familiar with nuclear science, together with the help of your presentation.
Okay, I think just to consolidate what you're saying is that I think the field of nuclear is very like a lot of people don't know very much about it. It's one of those things that are just out there, and you only know about the nuclear energy and how dangerous nuclear is. But there's so much that can be done. It's not even just nuclear medicine. There's a lot. There's even the food that we eat. Some of it is nuclear is irradiated so that it keeps well. So there's a lot of use for nuclear. So there's a lot to do in there. So I hope some of the guys will go in that direction.
Thank you very much. Thanks, Nozipho. Vilna, you've got your hand up.
Yes, sorry, Yancy. I don't want to steal the time of the students, but before our speaker goes, I saw on the one slide that they can actually treat Alzheimer's with nuclear medicine. And I thought, you know, there's so many people affected by it. Lately in one's family, you will see that. So I just wanted to ask about that. How does it work? Is it too much of a discussion? Then I can talk to you on email.
Yeah, sure. I think maybe on email, but what I can just mention quickly, it's mainly what we would do is diagnose it. So what happens is that generally the neurologist, what they will do is when they see, they essentially are diagnosing it on the signs that the person is giving. So it's not, sometimes you find it's actually other things. So what we can do is then point it out clearly that it actually is Alzheimer's, then you can get the treatment for that. But sometimes you find it's not even Alzheimer's, it's something else. Then we're able to show the changes in the brain to be able to see that, okay, this is what it is and this is what it's not. And then they can give you the most relevant treatment. So it's actually quite a useful thing. Yeah, but then we can talk more about it.
Okay, thank you very much.
Thank you, Vilna.
Okay.
Right, any other question for Prof Nyakale? And then I'll take I'll take a few questions while we're waiting for Dr. Lepoto.
I'm also going to have to run off. I have another engagement, so I'll have to run off in the next 5 minutes or so.
Okay.
Hopefully less. So, but any questions, my email, anybody can just email me and then I'll be able to talk to you and we can.
Okay, fantastic. Okay. Students, any questions for Dr. Nyakale?
Hi.
Yes, Ria.
Yeah, just a quick question. So, at any point, at any time in your career, was there a time where you felt burnt out, where you felt like you couldn't make any progress, or where you felt like you just had to give up? What keeps you going in that sort of situation?
Yeah, I think burnout is normal in that there are times when you feel like there's a lot on your plate, but to be honest with you, I have never felt like I want to give up. I think, in fact, I've been lucky in that I've got the type of mentality that you don't have to necessarily stay where you're not flourishing, you know? So I think that's the first reason I actually left. I mean, I was doing well where I was. One of my mentors is Prof Sate, but I felt like I could be more than what I was. So every time the reason I came to the job that I'm at now, I felt like I had reached where I wanted to reach in academia. So essentially, to give you an answer to that is that not really. I've never found myself in a place where I thought this is it and I'm tired and I don't know what to do next. I always am very willing to go to the next phase. Like right now, I'm here, but I'm still looking forward to see what the next few years are. So I believe I work in 5-year plans. And then when the 5 years, I have to reassess and see, am I happy here still? Is this what I want? Can I get big? Can I grow more? Can I do more? Right now, I do want to find myself doing other things. So yes, no. The quick answer is no. I get tired like normal people, but I still keep going. And actually, I think the reason I keep going is because I get tired, and I think this is enough of this now. Let's go to the next thing. So yeah.
Wonderful.
It's that whole loyalty to yourself. Not that you mustn't be loyal to others, but be loyal to yourself as well.
Right.
Can I please ask that you excuse me? I'm so sorry that I'm leaving in the middle of this. I wish I could attend all of it. But
Certainly, Prof. I hope the students will be in touch with you, and thank you very much for your wonderful presentation.
Thank you so much. Okay, have a great session and a great day.
Thank you.
Thanks. Bye.
Bye. Yes, I want to say, following Prof Nyakale's presentation as well, that the science community, broadly speaking, it's a very undefined term, you know, what the scope is of the science community. But the science community, in my experience, is a very supportive community in which you can grow and you can risk being inventive, changing careers or fields, let's say fields, and you can find mentors to allow you to grow in a new field. So this is an advantage, you know, that you are in STEM, in science, broadly speaking. Right, any questions for Professor Gledhill? She is still with us, or she came back to us specially. Thank you, Prof Gledhill. Students, do you have any questions for her? Now's your chance.
I do have a question.
Yes, thank you, Ria. You're full of questions.
So, saying that you're from a very theoretical background, so what sort of techniques did you use to make your studying more effective?
Okay, I think the first one is to be aware of having deep knowledge in a particular place, but needing to build bridges which actually come from fairly superficial knowledge to the experimentalists, to other theoreticians, to people who understand stuff that you don't understand. So I'd say that there's nothing as practical as a good theory, but it's got to be tested. Engineers would never do anything without a design cycle, right? So you make, for example, a policy, and then you test it, and then you find the problems, so you redesign, you test it, and you take it around that loop. And that means that you have to talk to everyone involved in whatever the output is.
Okay.
Did I answer your question, or you're actually asking something that I missed?
Ria?
Oh yeah, I heard that. That was a pretty good response. But what I sort of wanted more was, I think that you're a person who's like a lifelong learner. What do you do during your study sessions to, studying can take a lot of time. So what do you do to sort of study more effectively and sort of maximize the time that you have?
Okay, research is what you're doing when you don't know what you're doing. I get discouraged. I have a reaction when I come across a new obstacle, because you're always dealing with obstacles in some sense, but if you come across a surprising obstacle, my reaction is a physical one. I jump up from my desk. I have learned to control that sometimes. But if it's strong enough, I go and do one of a couple of things. For a minor thing, I can walk around for a bit and try to think it out, calm down at this obstacle and figure out what to do when I get back. The next one is I go and have a sleep, and then I come back. It looks different after that. And the third one is I go and read some very light reading indeed. This stuff happens all the time. I try to slice what I'm doing up. It's the salami method. No one would take a salami sausage and just eat it. But if you slice it very thin, it becomes more palatable. There's one more thing that helps me a lot, because I can't always keep my attention on what I'm supposed to be doing. So I have pieces of paper on which I write down the next thing, and it's a small next thing. Like it could be find the file, open the file. And then once you've done that, usually your mind starts running along what should be done. Or it could be like equation 9 or equation 52. What is kappa? Just go and find out what kappa is. And that's all you have to do, and that's easy. So that would be my reply there. I never understand what I'm doing.
Interesting.
Thank you, Ria, for your reaction.
Yeah, thank you very much, Ria, for that question, and Igle for that answer. I like that. Any further questions? Students, we haven't heard from you. We've only heard from Ria. Typical students, they don't want to speak up. Well, you're going to have to email Prof Gledhill and ask some questions of her. Because there is lots to talk about and lots to understand.
So I have a question for any student who cares to answer. And Jansi, of course, the timing is up to you. Do you find you're under pressure now in September? Especially pressure to meet expectations?
Yes, who would like to answer that? You can just unmute yourself and speak.
Should I start?
Yes, go for it, Ria.
Oh, yeah. I'll say I don't really focus much on what's happening on the outside. I just try to focus on one day at a time, 1 week at a time, and then I focus on what I'm supposed to do on my side, and I don't focus on things that I can't control, because it's just wasting energy trying to control things that you can't. So I just focus on what I can control.
That is a technique that's used by a number of people. I don't know if you've ever come across. Look, I hate books that come from booksellers that tell you how to live your life. But I was at one stage forced to read a book called The 7 Habits of Highly Effective People. And that is one of the 7 habits. To have a sphere of influence, to know what your sphere of influence is, and not to spend a lot of time trying to change the world outside that. Of course, I transgressed that boundary. Anyone else?
Changing the world is kind of outside that scope, isn't it?
Anyone else who has a thought on this particular time of year, September? Oh, right. For those students who are actually asleep, there is some very interesting research about transferring transferring what you've just learned from short-term memory into long-term memory. And a very good thing to do is to sleep. That transfer is understood, and I can't cite the research at the moment, but I do pick up these things occasionally, and it's in the proper literature. A very good thing to do is to sleep over lunch, have a siesta. It helps your brain function.
Right.
The thing is to remember to wake up before about 5 o'clock in the afternoon.
Okay.
Okay, thanks so much, Yancy.
Why? So the idea is to have a short nap.
Yeah.
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 That
An
is
hour is good, but I think shorter can be good as well.
okay. Right. The power nap. Yeah.
Yep. Yeah.
Thank you very much.
Okay, it's a great pleasure. I'll go and take a micro sleep now.
Okay, enjoy.
Okay, righto. Thanks so much. It's been delightful to meet with everyone.
Thank you very much.
Thanks, Ria. Thank you to all the speakers. I'll leave now. Thanks.
Okay,
Good luck.
goodbye.
Bye.
Right. Thank you for that. We are not getting hold of Dr. Laporto. Maybe she's having difficulty with the connectivity as well. But we still have 10 minutes until 2 o'clock. So what would you like to talk about, students? Our speakers have gone, but there are so many things that are thought-provoking in today's talks. Has anyone ever told you that you cannot do something? That you will not be able to? That you will fail?
Yeah, I've heard that quite a few times.
Yes, yeah.
I think the first time I experienced that was in high school, like in 9th grade or so. I had a couple of friends who said, nah, you can't really do this for the rest of your high school career, but I proved them wrong. So
Good.
You just said that, yeah, you shouldn't focus really on what other people say because they're just saying things without proof. So,
yes.
Yeah, I just, even today, I don't really focus on negative energy anymore. Yeah.
Yes. Yeah. No, I've certainly found that as well. I had a preacher in a minister of religion when I was in high school who said some discouraging things about architects not going to heaven, and I decided not to become an architect. Which, well, the rest is history, so it's okay. But you know, there are people who can be very discouraging. I also had a colleague who believed that women couldn't distinguish 3D, couldn't have 3D perception. And he was incredibly intelligent and creative and someone I really looked up to. But it's strange how people can have these stereotypes of what you can't do if you're a particular kind of person. Did anyone else come across that? Did anyone tell you that you would not do well in matric? Oh, Mr. Chiloane, I didn't actually realize that you're still in the Zoom. Any questions for Mr. Chiloane? If you don't want to reveal what you've been discouraged from before. A number of speakers were talking about taking on a leadership role, especially Prof Iwuoha was emphasizing very strongly that that you should be a leader You should take on the responsibility of being a leader. And then other speakers also referred to that. Mr. Chiloane specifically said that he had to overcome the imposter syndrome, get over it very quickly, and take on a leadership role because he found himself in that position. So what do you think about that? And Mr. Chiloane, would you like to tell us what that was like?
Yes. So what happened in my case is that I was really being trained by somebody who was approaching the end of his career, like really mature. So he knew everything in the field. And if you compare yourself to that as a baseline, you will always fall short. So it really, I had to overcome those negative feelings because I always felt like, oh, I can't measure up to this person. But I had to put it into context that I'm at the stage I'm at, and that's how I approached it. And yeah, it's interesting because when you really just get rid of those negative feelings, you can find opportunities along the way. Because this is what happened in my case. I was thrown into this position in an acting capacity, but then 6 months later, I realized that I actually like this and I can do it permanently. So I went for it.
Yeah, fantastic. That is just wonderful. Taking the opportunity with both hands, hey, and running with it. Wonderful. I think it's quite often for people who are a bit nerdy, who like science and technology, and who excel in those areas. You know, sometimes we are a bit introverted, a bit shy, and we don't want to step out of that comfort zone. It's quite uncomfortable to take up the leadership role and to be something that you see other people doing, but it doesn't come naturally. Any students who want to share their experiences in that regard? And you know, when I met you on the tour, when I met all the students on the tour, you know, everybody has different personalities, and everyone approaches their interaction with other people in a different way. And there are some who take some time to warm up to other people and to interact. And then it's not easy to then take a public speaking role, take any kind of leadership role, to initiate a conversation, that sort of thing. So it's very heartening to hear from the award winners that that they have had experiences like that as well. Okay, I see in the chat that Dr. Leportu is not able to join us.
All right. Thank you so much. I have to move on to another
Yes.
thing.
Thank you
for
very
the
much, Leo. Mr. Chiloane, thank you very much indeed for your very interesting talk. Oh, I also enjoyed that you said that you read everything, including fiction. That is wonderful.
Thanks.
Thank you.
Bye. I just asked something before he leaves.
Oh, he's left
so
already.
Oh no.
Go for it.
Yeah, maybe you can answer. Like, as a, when you take up a leadership position, how do you deal with criticism? People who criticize anything. So how do you deal with the criticism from people?
Mm-hmm. Okay, I'll answer that. You grow a thick skin. You know, there's that expression that if you have a thin skin, you're easily offended. So you grow a thick skin so that you don't get bothered by it. But no, it's not easy, actually. It's because you also want to be, as a leader, you have to be able to listen to people. And to get that kind of balance where you listen to people, but you don't get discouraged by the negative things that people say, that is something that, a skill, I think, that you grow over time. For some people, again, it comes naturally. It kind of, some people believe in their own vision and their own leadership so strongly that they go ahead and it seems easy, and they don't get discouraged. But if you are sensitive to what other people are saying, you could be a very good leader because you're actually listening to what people are saying, and you're using that to inform your own actions and your own words. But then you have to learn to ignore the negative things and the negative criticisms. And I think all of these speakers today have actually managed to do that. You know, they're all in leadership positions. And as they explained, you know, it didn't come naturally at first. And they had to learn how to do it and how to ignore the negative and the criticism. Anyone else want to add to that? Comment on that discussion? Which talk did you enjoy the most? We're actually at the end of our time here, but I would really like to hear. Ria, which talk meant the most to you today? Can you say?
Oh yeah, I think it was the last one. I think it was Dr. Lipoto. Yes, I think that was, it sort of went a bit more into, you know, psychology. So I think those really good. Yeah. In my opinion.
Sorry, which one was that?
The last one, I think it was by Dr. Lipoto.
Or Chiloane? Dr. Lipoto
No, Dr. Lipoto.
No, it's Prof Nyakale.
Oh,
oh,
yeah. I miss.
From the nuclear medicine perspective.
Yeah.
Okay, thank you, Ria. What was the most interesting for you, Kumani? Kumani Maite?
I wanted to say that I enjoyed Prof Patience Mthunzi's talk. I also enjoyed the other talks, even though the other speakers might have confused me there and there because of the complexity of their studies in science, but all the talks were very motivational, and I think we've benefited a lot from this. And I would really love to take on the leadership advice that we were given, but I'll see where I start because I don't have a start. But yeah, I enjoyed the talks, mostly Prof Mthunzi.
Okay, fantastic. Thank you, Kumani. Thanks for sharing that with us. Yes, the leadership thing is quite a lot of pressure that was put on you by Prof Iwuoha. But that is something that comes with time and experience, and you will see how you go. It's not a given, although as a scientist you are often in positions where your voice is valued and your opinions are valued, and that is a good start in terms of becoming a leader. Kamohelu, would you like to tell us which talk you enjoyed the most? Or Mpumi? You're both muted, you know that. Okay. Thank you for staying on overtime and for attending today. I hope that you benefited from it and that you'll go back and just fast forward through some of the presentations and pick up some of the nuggets of wisdom that these wonderful people have left for all of us to pick up. And all the best with your exams, with your studies in the rest of the year, and we will be in touch. Italy especially will be in touch. Yes, Kumani.
I wanted to ask, will we be able to get access to the presentations so that we can use them in case?
Yes, yes, they will be on the website, on the NSTF website,
Okay,
nstf.org.za, on the event page under Brilliants, under Youth.
okay, thank you.
Yes,
Okay.
I've also posted the links in the chat. So if you want, you can quickly go to the chat, click on the links, and it will open the places where you will find it within the next few days.
Yeah, thank you, Vilna. Okay, thank you, Itu, for organizing this for us today. Thank you, Jane, Ashley, and I think Mankwe, for your work and for attending. And thank you to the students. Thank you, Zinhle, for posting on social media. The students, if you go on social media and you follow NSTF, you will see some of the posts about today. And please share them. Please share the link to the event page as well, and any presentations that you found valuable. Share them with your fellow students. Okay, all the best. Great to have had you here this afternoon, today, since this morning. Okay, bye.
Bye, everyone.
Bye.
Bye, and bye, Kamani. Keep well. Goodbye.